All right. Hello, everyone. Can you hear me okay? Yes. Well, so nice to see everyone. I'll admit my favorite part of doing these things is just seeing from all over where everyone is. In fact, looking in the chat here, we have India, we have New York City, we have Ethiopia, Mexico, Argentina, Minnesota, Malaysia, Canada, Kuwait, and on and on and on. So it's so nice to see everyone all around the world. Here in Cambridge, Massachusetts, USA, it's 9 p.m. on the evening side, but surely it's morning or afternoon where some of you are as well. So this is the last, literally the last of CS50's New Year seminars. Over the past few weeks, our team's been holding seminars on Python, on SQL, on game development and Linux. And if you missed any of those, all of them are still available as recordings on the course's website. We've also been joined over the past few weeks, as well as tonight, by over 700 volunteers who've offered to mentor and answer questions in the chat window here, and also on Ed, the course's Q&A platform. So indeed, if you have any questions tonight, you get a little lost, by all means, ask in the chat window itself or afterward on Ed as well, the Q&A platform. We have this tradition before we begin of taking a group photo. If you would like to participate in this, go ahead and turn on your camera. We'll give everyone a moment to do that. And also rest assured that tonight, if you find that it goes a little too quickly for you, if you have technical difficulties, if you have trouble getting the software working on your Mac or PC, no problem. Everything will be freely available on the course's website after as well. So feel free, if you get a little lost, to just follow along as best you can, watch and listen and learn, and then try things hands-on when you are ready to. All right, let's go ahead. If you would like, put on your happiest smile and wave. And our colleague Tara behind the scenes is going to go ahead and take a whole bunch of screenshots. Hopefully we'll catch you at a good moment. And then we'll run some special software later tonight and stitch them all together into one big mosaic that we'll post on the seminar's webpage as well. How are we doing, Tara?
Also, David.
All right. Thank you to Tara and to everyone for partaking. So I am so pleased to welcome back as tonight's teacher, CS50's own Colton Ogden, who teaches as well GD50 or CS50G, which is the full course on game development that's freely available via edX's open courseware. Indeed, if you like tonight's taste of game development, realize you can go and learn another dozen games and all of the fundamentals beneath them. And indeed, what's particularly fun about game development is, of course, after you get your code working, you and your friends and your family can actually play what it is you have coded. So without further ado, over to Colton.
Awesome. Thanks, David. Welcome, everybody, to indeed the last seminar here, which is pretty crazy. Very happy to have all of you here. This is indeed a sort of taste of game development. So this is, of course, pre-CS50. If things feel a little bit too fast, if there's a little bit too much technical overhead, rest assured, that's perfectly normal. Games are a little bit on the trickier side to get started with and get set up with, but we will try to take things as well-paced as we possibly can. I'm going to share my screen here really fast, just so that you can all follow along with me. Let me share that. So if all is well, you should now see my slide deck. And in addition to that, I'm going to make sure I have the chat visible so that I can read in case anybody wants to send any messages my way. Do feel free to post in the chat if you have any questions as we go through this seminar. We have a bunch of awesome mentors who are able to answer some technical questions. And if any questions by chance are unfortunately not able to be answered during the session, do post on the Ed discussion forums where we have been currently addressing other technical questions. So as you can see by the slide here on my screen, or on your screen, we have in the very center sort of this old school 1970s Atari Pong console, because today we're going to be taking a look at how to implement the very game Pong, or at least a derivative thereof, using more modern sort of ways of implementing Pong. Back in the day, unfortunately, they didn't have access to the programming tools that we have now. They had to actually hardwire the circuitry for the arcade cabinet that they ended up making Pong with, which is pretty technically impressive. But we'll be doing things a little bit more easily today with a framework and language called Love2D and Lua, respectively, although they are flipped on the screen here. On the left, you can see there's an icon for Lua, the programming language that we'll be using. And on the right-hand side, there's an icon for Love2D, which is the 2D game framework that we will be using. Basically, a collection of these sort of Lego boxes that have a bunch of building blocks for us to create games with without having to necessarily create everything from scratch. The important sort of step in the beginning for us to get started on a technical note will be to install Love2D, which also does come with Lua included therein. You can get access to Love2D via love2d.org. At the very front, you'll see a distribution for your operating system, whether you're on Linux, Windows, or Mac. And we do have links being posted in the chat, thanks to Valerie and others who have links to various resources on how to get set up with Love2D on your computer, whether it's for Windows or Mac. And specifically with a particular setup that we recommend at CS50, which I will demonstrate for all of you. So I'm just going to quickly open up the website here, Chrome, so that we can see the love2d.org homepage. This is where you can download Love2D. You'll see at the very center here, we have all the distributions for Windows, Mac, Linux, and even distributions that make it possible to run it on Android and iOS. In addition to that, there's a getting started page, love2d.org/wiki/getting started, which is also linked to my slide deck, where you can see how to get set up on all of your operating systems in a bit more detail, including even iOS and Android. So do get set up with that, download that, get it installed on your operating system. We officially recommend, at least for this seminar and for game development and also for GD50, which is the course that I teach that branches off of CS50, Visual Studio Code, which you can get at code.visualstudio.com, which I will go ahead and link to in the chat as well. And what this will do is give you access to not only a great text editor, which is what Visual Studio Code is, but also a particular plugin. So if you follow the instructions that are listed on the seminar website of CS50's, there's some instructions for how to get set up with this. Essentially, once you download Visual Studio Code, what you're going to want to do is in Visual Studio Code, I have it here opened up on my computer. You'll go to Can everybody hear me? Is everything okay? It would seem that Zoom for some reason crashed. Okay, apologies for that. Let me reshare my screen. I'm not sure why that happened. First time, saving the best technical difficulties for last semester here. So it's our last seminar. Let me share my screen there. And so now you all should see my VS Code again. I need to pull the chat back up real quick. And while we are taking this sort of unexpected little diversion here, I want to make sure I read the chat just to see if anybody if anybody is asking any questions that I can pluck off really fast here. Looks like everyone's still introducing themselves, which is awesome. Like David said, tons of locations here across the world, which is super awesome. I personally am in Las Vegas, Nevada at the moment. Fantastic. Okay. So transitioning back to a hopefully functional Zoom and a hopefully functional screen share, you'll see that I have on my computer here VS Code. If it's been properly installed, this is what you'll see on your machine. And if you go over to the extensions menu over on the left-hand side, which would be Control-Shift-X or Command-Shift-X on your computer, depending on your operating system, you'll see if you type in Love2D, there's a Love2D support plugin, which we recommend using because it makes running your games via Visual Studio Code much faster because it pulls up Love2D directly rather than having to maybe drag your folder onto Love2D or use the command line to execute Love2D at whatever current directory you're working in. This just lets you do Alt-L or Command-L, depending on whether you're on Windows or Mac, and very quick, you just pull it up. If you have any issues getting this running, getting this configured properly during the seminar, don't worry. You can always click and drag your folder onto Love2D in the time being. But we do recommend if you can try to get it set up on your computer, this is a much better workflow. So I have it all set up, of course, on my computer. And then all of you, hopefully, there's a set of instructions on the CS50 seminar site with more detail on how to get that set up for Windows and Mac. So do give that a stab. So we recommend Visual Studio Code with that plugin. That being said, basically, once we have all of that, technically accomplished and set up and ready to go, and I understand that it can be a little bit much to get started with, especially if folks are new to programming. Which, if you are, and some of this feels overwhelming, don't feel bad at all. It's completely normal. It happened to me at one point a while back, so totally normal and expected. So I'm going to transition now back to my slides because before I get into actually writing some code, I'd like to spend some time really kind of talking about, in the abstract, at least for now, and to a slightly more technical degree, what a game is, or at least how I conceptualize a game. So I like to think of it kind of now as a flip book, so to speak. Now, a flip book is just basically a bunch of pieces of paper together in a little pad or a little conglomeration that you can flip through really fast, as shown by this picture here. And the goal is to sort of have a different picture on each page of the flip book, slightly different from the last, such that it feels like we are animating something, maybe a face making an expression or somebody jumping or doing any sort of number of things. This is in effect what an animation is, a 2D animation. It's a set of frames that change over time in subtle ways such that we feel like there's a real animation taking place. And games are really similar to this, except for the fact that games are like we are hand drawing the flipbook pages as we flip through it in real time. We are essentially updating the frames and then drawing them, or updating, I guess, in our minds, sort of what should be on the page, and then drawing it and then displaying it all in real time, 60 frames, however many frames per second. So that's how I like to think of games. In a little bit more technical or formal sense, a game is really an infinite loop of sorts that has a set of steps that repeat over and over and over again. Now, if you've taken CS50 or other programming courses, you might be under the impression that in most cases, if not all cases, an infinite loop is typically a bad thing. And oftentimes this is the case. Having an infinite loop on your desktop might manifest as, for example, an infinite spinning ball or the like, or something crashing eventually. And of course, these behaviors are bad. They're things that are undesirable, but there are some infinite loops that are functional and are actually essential for certain things to exist. For example, servers on the internet have to infinitely be listening for requests from clients, from folks using, for example, their web browsers to interact with websites. Web browsers themselves have an infinite loop that's constantly refreshing the pages of websites. And games are an infinite loop, essentially, of a set of steps that happen in sequence: processing of input, updating of the game state, and rendering of the game state. And this repeats over and over and over again, usually 1/60th of a second per iteration of this, to give us the feeling that we are, in fact, living in some world or doing something, when in reality, what we're really doing is these set of discrete actions and giving us the illusion of existing in some sort of reality. So again, processing of input, pressing a key on your keyboard, using a mouse, using a controller, what have you, updating the game, so moving all the things on the screen, making sure you keep track of their XY or XYZ coordinate values, maybe doing that multiple times per second if you're on a slower machine and you skipped a frame or two, and then rendering, that is drawing everything onto the screen on the monitor, because normally, or prior to this step, all of your game state is essentially a bunch of values in memory, not really doing anything. So to actually show you the game and have the feeling that you're looking at something moving or interacting, you want to, of course, render it to the screen. And then, of course, this goes back on the next frame 1/60th of a second later to the process input stage, and then it repeats over and over and over again ad infinitum. So I'm just going to peek over to the chat real quick. Some folks are suggesting alternatives to Visual Studio Code, which is great. Yeah, you are absolutely free to use whatever gets the code written and saved on your computer, such that you can run it with Love2D. It will work. Any text editor at the end of the day is perfectly fine. But we officially recommend Visual Studio Code primarily for the plugin, and also because we think it's a pretty good text editor. All right. So that is what a game is, sort of in an abstract sense, and in even a slightly more technical sense. Now, what I want to do, whoops, I accidentally closed my chat here. Let me reopen that real quick. So what I would like to do is get back to or transition a little bit towards making this or taking those ideas and writing them out in code and getting us started actually interacting with code on our machines. So somewhere on your computer, you're going to want to create a folder anywhere. It doesn't really matter what you call the folder. I have a folder that has all of the seminar code thus far from the first 3 iterations of the seminar. And within this folder, which is loaded in VS Code, you can click and drag a folder into VS Code to open it up. I'm going to create another sort of subfolder called Live 4, because this is the 4th live seminar of this iteration of this particular talk. And within Live 4, I'm just going to create a new file. You can control click or you can right click to do these actions. You can also hit Control N or Command N, depending on your operating system, to create a new file. And I'm going to call this main.lua. And this specifically needs to be called main.lua because this is a file that Love2D is going to be looking for when you launch it. It specifically needs to be main.lua, spelled just so. And you can kind of analogously think of this as the main function in C or C++ or Java, or even the sort of main sort of string that you look for in Python when you launch a script and you want it to run. If anybody is familiar with any of those languages or domains. In the same vein, we don't need a main function in Love2D, but we do need this main.lua file to exist. In addition to this, once I have the main.lua file created, I'm going to write a little bit of simple code here. I'm going to create a function called love.draw, and this has to specifically be called love.draw. This is something that the Love framework is going to be looking for once we've installed it, once we run it. And then within love.draw, I want to call another function called love.graphics.print. And within that, I'm going to pass an argument, a string that just says hello world. And then I'm going to save that. So this needs to be love.graphics.print. Love has a bunch of these sets of awesome boxes of functionality. For example, love.graphics is one of them, and it has this ability to print things to the screen. And then love.draw is a function specifically that it knows, okay, if I open up my script file, my main.lua, and I see love.draw in there, that's the code that I need to run, that I need to draw to render onto the screen. It's a callback to the diagram we just looked at. It's that render piece at the end there. I'm going to run this. Now on my computer, I have the plugin installed, so I can just hit Alt-L and it's going to just run it, which is super convenient. If you don't have the plugin, you're unable to get it installed, you can take this folder with main.lua and drag it onto the Love executable, and that will also do the same thing. It'll accomplish the same thing of running the program. And make sure not to drag the main.lua itself, but rather the entire folder, because Love2D does expect the folder to be passed into the program, not the main.lua. All right. Sarah asked, how do we add comments? Simply by doing --, you can add comments to your code and then type whatever you want. And then VS Code here, for example, is showing us the comments in green. So hopefully folks are able to get that up and running. Pranshu is asking if there's main. There is no main function. We do not need a main function. The main function is the equivalent of you creating this main.lua. Essentially, there's a little bit of magic going on where Love2D is going to look in main.lua for a particular set of functions. It's going to plug them in to that infinite loop we were talking about. It's going to manage that for us, and we don't have to worry about that ourselves. But we do have to implement several of those functions, those pieces that we looked at in that diagram. All right. Do we need push.lua? So yep, we will be getting to push.lua. So how do you create a while loop? A while loop in Lua is while some condition. So while, let's say I is less than 10, do, and then this set of code that's inside this block here. We're actually not going to be using infinite loops in this seminar, but if you wanted to use an infinite loop, you would do a loop of this form. So while some condition, do this stuff, and then end. Notice that there is an end keyword, not only after this while loop, but also after this function. So anything that's a block in Lua, much like in the way that C has curly brackets, needs to have an end thing to sort of denominate or to denote that we have reached the end of that particular block. So do make sure your function has an end to match. So that is the love.draw function. If we come back to our slides here, you can see sort of that we have the this render block here at the end of this loop. So Love2D is effectively what it's going to do, and we're going to implement the rest of this shortly, is it's managing this infinite loop for us. So we don't actually have to hand code an infinite loop, but we do have to hand code these individual pieces of the loop such that Love2D can basically take them and insert them into the right place, and then magically our game will just sort of work. But we do have to take care of making sure that we have all of the pieces ready to go so that the loop that Love2D manages knows where to find the pieces and where to put them in. The render is the equivalent of love.draw, which we just wrote. If we wanted to fill in those other pieces just temporarily, we could say function love.update, which takes in a parameter called dt. We won't write anything within this currently, but this is the analogous piece to the update block on that diagram. And then additionally, function love.keyPressed, which takes in a key, is the alternative or the analog to the process input stage of that diagram. So you can see here, this is the love.keyPressed, love.update, and then love.draw accordingly. I heard a little bit of noise in the Zoom. I hope somebody wasn't trying to contact, or I hope my microphone's not bugged. Everyone can still hear me okay, right? No one's trying to get my attention at the production office there, hopefully. Okay, awesome. Happy to hear you. All right. How do you print something to the console? With Love2D, to print something to the console, you actually have to pass an argument to your love.exe. I think with the settings actually in Pixelbyte, if you come over to the cogwheel here, if you're on in VS Code, and you go over to the extension settings, there's a debug option right here, which allows you to show a debug console as soon as you run the game. And then in that debug console, you can type in different functions like print, which will allow you to actually print directly to the console instead of to the game window. So that is an option for you right here. And if you're running it at the CLI, there's a dash dash. I don't remember the exact argument, the command line argument for it, but there's a dash dash something or other that lets you, might be dash dash debug, which allows you to do the same functionality at the command line. So good question. We will not be using that during the course of this seminar, but it can be useful to know if you're debugging, if you're trying to do something sort of behind the scenes, data structure wise or whatnot, that can indeed be helpful. All right. So some folks are already slightly ahead in that they're looking at the push.lua file, which we will be using. The way that I'd like to segue into that, I guess, is taking a look at the window here. We can sort of see when I run this that the text on the screen is very tiny. It's located at the top left, this hello world text. And the window, it's of course using the native resolution of my screen, which I'm on a 4K monitor, but this will look small even on a 1080p monitor. So what we want to do is probably remedy this. Now, the reason that especially aesthetically I'd like to remedy this is if we're looking back at Pong in the slide deck here, we can see that it does have this sort of crisp, pixelated retro look to it. And older games of this style, you know, whether you're talking about Atari or NES or Super Nintendo, Game Boy, whatever, older school sort of games that harken back to the 8-bit or 16-bit era, which GD50 in particular takes a lot of inspiration from to get people familiar with game development. In order to get that aesthetic, we can't really draw to native screen resolutions because they're much higher pixel density than the screen resolutions that existed in days long past. So to get us in that direction of being able to think of our game in terms of like a retro game, but be able to still code it and draw to on our computers that are now obviously much higher resolution, we can use a library to actually sort of abstract this idea away. And indeed, I saw Valerie post a sort of a link to that in the chat previously, but if folks missed that, there's a link to a library on GitHub where you can download the zip for it or clone it if you're familiar with Git. And there's a push.lua file located in that bundle. So you're going to grab that, particularly that push.lua file, and then you're going to want to put that inside the same folder that your main.lua currently is located. Now, I have a bunch of iterations of this talk already that I'm just going to take a push.lua from one of those. I'm going to copy it and paste it into Live 4, which is the current seminar that we're working on right now. But you'll, of course, need to grab it from that zip on GitHub or that repo that you cloned from GitHub. And there's a bunch of crazy contents in that file, that push.lua. Don't worry about any of those. We're really going to ignore it for the most part. We are going to use it as an abstraction. We're going to use it as a library. We're not going to worry about the contents. We're only going to worry about its functionality. The goal of this library is to get us to be able to think in terms of virtual resolution. So in other words, being able to write to something like 384 by 216 pixels instead of 1920 by 1080 pixels or 1280 by 720 or 3840 by 2160 on 4K. We want to think in terms of much lower resolution for the sake of at least this talk. So a few steps in this direction. Before we get the screen being changed into this new resolution, we have to, of course, decide what resolution we want. So I'm going to create a few variables up at the top of the screen. So I'm going to capitalize them to denote that they should be constant. In other words, they shouldn't be changed. Now, Lua is a dynamic language, so I technically can change these variables later at any time. Unlike some languages like C, where if you declare them as constant, they cannot be changed down further in the code. I'm going to assume anytime I see a capitalized variable, it should not be changed beyond its initial definition. And this is just a convention that you can use to communicate to yourself or other programmers in the future that this is how you want these variables to be interacted with. So I'm going to say virtual width should be equal to 384. virtual height should be equal to 216. This is just a 16 by 9 resolution that I particularly like, that I feel fits this seminar pretty well. I'm going to also need to decide what my actual window resolution should be. You notice that already it's a bit more square-like instead of 16 by 9 aspect ratio. So let's fix that by defining window width to be something like 1280 and window height to be, let's say, 720. So it's another 16 by 9 resolution. The two are equal aspect ratio, so they'll scale up and down with each other very nicely. And then, of course, we have the push.lua file in our project, but we need a way to actually use it. So if I say push is equal to require space and then the string push, what this is going to do, if you're familiar with something like import or require from JavaScript or Python, this will load the contents of push, the push.lua file, which it automatically assumes is the case if we don't specify .lua here. It's going to load the contents of this file into this variable. So now we have access to all of the functionality of push just located within this, which we can now use to set everything up correctly. All right, just going to take a look at the chat here. So Amy's saying it's interesting with Mario. Indeed, yeah, it's nice to be able to see it on something like Mario. Pong, admittedly, is a bit simpler in that it is shapes and text for the most part that we are dealing with, but it's still helpful to get us interacting with not super high pixelated, sort of crummy looking games when especially if we're talking about fonts that are being rendered at native resolution. Sometimes it can look a bit amateur, I suppose. And admittedly, I'm sure many folks, this might be their first time game programming, but even still, small little things can add up to making a big aesthetic difference. So, and especially with things like sprite art as well. Okay, so we are going to go ahead and forge ahead. So somebody asked, how do we add code comments? That's dash dash, just like this. Alternatively, you can do dash dash hard bracket to do a block comment like this. If you're familiar from languages like C++, C, or Java, those exist. Now, what I want to do is get the push library to actually draw things in our virtual resolution appropriately. So what I'm going to do, above all of the functions that I've already written out, I'm going to write a new function called love.load. This is another function that love will look for when we start our game and will plug into the right spot. So these functions are all specifically named such that love2d will locate them and find them. We just have to worry about what they do. We don't necessarily have to worry about where they go. That's what love2d will take care of for us. Within love.load, what we want to do is say push colon. This colon is important. Make sure you do colon and not dot here. Setup screen. Notice the capital S there. So a colon here just is sort of a signal that says, okay, push is a sort of, you can think of it as an object that has a function or a method called setup screen. We don't need to worry too much about sort of the differentiation here between colon and period, but know that there is a difference. But we'll only be worrying about colons with push and only the push functions. So just sort of take that right now sort of at faith. And then within setup screen, what we're going to want to do is pass in 4 arguments. That is virtual width, virtual height, window width, and window height. So taking in the pair of virtual sort of resolution arguments and then the actual window resolution arguments. This is getting it set up to draw to a 1280 by 720 window, our canvas of 384 by 216 pixels. So no matter actually really what the size of this window is, it'll always look like it's 384 by 216. So it's nice in that regard. And there's one more step before we can actually get this running properly, and that's to say over the down in the love.draw function, right above the code where we're printing things out, and this is going to encapsulate all future drawing code, we want to say push colon start and then push colon finish. So before is start and then after is finish, just like that. Note the colon and note the parentheses to trigger the function call there. So once we've saved our file, once everything is written out just so, and we rerun the program, you'll notice that indeed, it's not only now a 16 by 9 aspect ratio window, but we also see at the very top left, hello world written out, albeit really blurry looking right now, which does not fit the crisp sort of aesthetic we're looking for, which we will remedy just now, actually. But let me just take a look at the chat, make sure everybody's doing okay. What was the point of defining all the variables? So the point is that now we have an easy reference to these particular numbers in the future anytime that we need to use them, which we will need to use them going forward beyond just the setup screen function here. You don't typically want to have a bunch of what are called magic numbers floating through your code. If you've taken CS50, we do mention this in a few locations. You typically want to be more explicit rather than implicit, in which case, for example, defining them as virtual width, virtual height, and also noting the capitalization of them sort of signals that, okay, these are values that not only are, you know, virtual width, virtual height, not only do they have semantic meaning, but they're also not to be changed going forward. So that it serves a couple of purposes. All right. Module push not found, how to add it. Make sure that it is located inside your folder, wherever your main.lua is. It should be in the same exact location. So download it from the GitHub repo and then just drag the push.lua file inside that location. Push.lua is located at GitHub. People are kindly pointing to it in the chat there. And then, of course, if folks are having technical issues, no worries. Again, as David said, you can certainly follow along later. The code will be posted to GitHub. In addition, there is also Ed, the discussion group. So if you're having a particularly troubling time getting for technical reasons, getting your code or getting an editor, getting a particular program working, do try Ed as a sort of last resource in the event that mentors are unable to assist. But fortunately, we do have a lot of very nice mentors in the chat that are helping out with people. All right, so how to close Love2D after Alt-L? That's a great question. So currently, right now, all we can do is click the box. So if I were to rerun this, you can click the box by coming up here on Windows or on Mac or on Linux. If you're using a graphical version, I assume that there's a similar button. We're going to take care of both the blurriness and the closing the window issue right now. So let's take a look at that. So first thing, excuse me, that I want to do is in love.load. Currently, when we load up the game window, it is very blurry. The text is on the top left. It is much larger. We've accomplished the goal of making sure that we have a more zoomed in view of the game world, but the blurriness of the text is really off-putting and it looks really bad, frankly. So the reason that it's blurry is because, well, by default, what Love is doing is anytime it scales text or images, it's performing what's called texture filtering, and it's essentially zooming in or zooming out on pixels, calculating where in the new sort of map in individual virtual pixel is located when it performs that operation, and then basically interpolating between pixels to smoothen out where there are now gaps between pixels. In the world of retro style 2D artwork, this does not look very good, but in the world of, you know, high resolution artwork, this can look really good. This can sort of make things look a bit smoother and a bit more polished. But we do not want this. We want things to not be filtered whatsoever. So to avoid this, in love.load, we can say love.graphics.set default filter, passing in two parameters, nearest and nearest, two separate strings separated by a comma. So what this means is we're not going to use what's called bilinear filtering, which is the default filtering mode. We're going to use nearest neighbor interpolation, which just means whenever we zoom in or out of our textures, take whatever the closest pixel value is after we perform that scaling operation and just use literally that color. So we'll actually never use anything that's not already in the texture or the artwork that we're using. And this has the effect of effectively zooming in or out 100 without any filling in of pixel data. If we rerun this, you'll see that indeed this looks very much as if we had taken something like Photoshop or the like with a screenshot of our old sort of version of the game and just zoomed in over and over and over again. If taken CS50, this probably feels familiar too, with the illustration of zooming in on image data. Just a set of pixels. We can now literally see the individual pixels that make up that font data. And this will help us going forward when we draw future fonts, and especially if you get into drawing artwork, drawing sprites like Mario sprites and the like, this will look much better than using texture filtering. All right, taking a look at the chat here. Can I hide File Explorer, as in using something like that? Probably can, although I may not make a I may not mentally make a good enough note to do so, but I will try to. Let me continue looking up just to make sure I've not missed anything. All right. Okay. All right, going back to the code here. So the other sort of puzzle is that currently when we run the code, yeah, I'm probably not going to stick to hiding File Explorer because every time I run the game, File Explorer comes back up, and it's just a Windows quirk, unfortunately. So we'll probably keep the File Explorer visible for the sake of the demonstration. I apologize if that's bothersome, but we have our window, and in order to quit the game currently, I have to manually drag my mouse over to the top right and click the box, which should be kind of annoying. I would much rather probably do something like hit escape. And this allows us to segue back into, oh, it looks like the File Explorer ended up going back away. So maybe we'll leave it after all. We'll leave File Explorer hidden after all. But now what we can do is we can fill in the one of the other blanks in that diagram, the input, the update, the draw. We can fill in the input side of things because let's say I want to hit the escape key to quit the window. I need a way of detecting input and then triggering behavior based on that. So I can say something like in my love.keyPressed function, which takes in a key argument, this gets taken care of for us by love2d. So it knows essentially that if we've defined this love.keyPressed function, that it will call this function and it will pass in the key every time we press a key on the keyboard effectively. So I can say, knowing that love2d will give us the key anytime I press any key, if the key is equal to the string escape, and all key codes in love2d are strings, then we can use something called love.event. So another puzzle box, another Lego box of functions in the thing called love.event .quit, which then we'll use parentheses there. So if we call that and then I run the code, I can now hit escape like so. Didn't have to drag my mouse over or do anything, and the game quit. So now we know how to use input processing in our game to do various things, which will come in handy in coordination with love.update, which we'll see is also very important for doing input. All right, people are saying it's working, which is great. Very happy to hear that. Hello World is smaller than mine. Do make sure that you've downloaded Push and set up the Push library to use probably the same resolution. If you're using a different resolution, your Hello World may look larger or smaller. So definitely take that into consideration. Why is it named Love? I'm actually not 100% sure. I know there's a story for that. I think it might have been somewhat arbitrary, but you can probably find a forum thread or the like on the Love2D website as to the origin of that. Is there any way to automatically save code? I'm not sure about automatically, but you can certainly hit Control S or Command S if you're on Windows or Mac to do so. And is it possible that Mac keys have different string values? This is at least the case for the Enter key. So we'll see that come up in just a little bit, but on Mac, the Enter key by default is actually return. And that's the extent to which I know that there are differences. There may be others that I'm unaware of. Certainly, probably the Windows key or the Apple key or Command key probably have different codes, but that's about it. So Mike Co says Alt-L is not working. So apologies for that. Do try to follow the instructions, and if not, maybe post on Ed. But there are definitely certain steps depending on your operating system to get it working properly. So you're going to want to make sure that you follow all of those steps 100%. Okay. Window is huge, does not have an X button, so it might have gone full screen Arjun, in which case you want to probably output to a lower window size. So on default, for example, on Windows, I'm doing 1280 by 720 because I have Windows scaling enabled. If I go any larger than this, it will actually go full screen. So I'm going purposefully 720 instead of 1080. All right. So that is how we get input started. So now that we have that piece of the puzzle, let's go ahead back to our slides and take a look at the 2D coordinate systems. This is a very important topic in 2D game development. The 2D coordinate system is essentially the backbone of how we get things rendering onto the screen and moving around and behaving properly. Essentially, we can think of our game window as a 2D Cartesian coordinate plane with XY pairs. So you have the X-axis going left to right and the Y-axis going up and down, top to bottom, left to right. Starting at the top left at 0, 0. So positive X values will go towards the right, positive Y values will go towards the bottom, and negative values will go both to the left and up respectively And if we're starting at 0, 0, any negative values will actually go outside of the bounds of our visible screen. And of course, the far right edge is width, comma 0. The bottom left edge is 0, comma height. And the bottom right edge is width, comma height. Now, this is very important because in order to draw things properly in Love2D or in any 2D application, we essentially need to associate with everything that we draw a 2D coordinate pair, an XY pair. So why don't we go back to main.lua and let's seek to perhaps actually go back to our picture of Pong here. Let's seek to draw this very first top left paddle to get us in the direction of not just rendering text to the screen, but also rendering shapes and getting closer to some more interesting behavior. So if I'm going down to, or rather, first off, before we get to drawing things, let's actually think about our player in terms of data. So I want to have something called, let's say, player 1. I'm going to assign it to this thing called a table in Lua. And if you're familiar with Python or JavaScript, this is very analogous to a dictionary or an object, respectively. And what it allows us to do is to associate keys with values. We could say player 1 has an X, which is equal to some value. It has a Y, which is associated with some value. This is very similar to structs in C as well, if you've taken CS50. So for player 1, let's say I want an X, and let's say I'll give it 10, and then Y will be 10 as well. So this means if we're thinking about 0, 0 at the top left, 10, 10 will be 10 pixels to the right and 10 pixels down. I'm going to save it. And then I want to not only have my player 1 with an X and a Y, I want to also know, okay, well, I have this idea of where my paddle is, but I also want to know how big my paddle is, right? It's a rectangle. I know that much. So let's just say something like paddle width should be equal to 8 and paddle height should be equal to 32. These are constants. These will not change throughout the course of our game. That's why we have capitalized them with underscores respectively. Player 1, on the other hand, is not a constant. We are deciding that in the future we might change player 1. So we are using regular camel case notation. So lowercase initial value for every first character of every word within the variable name. And then also the inclusion of things like numbers. So we have our definition for the width and the height. We have our player 1, which is in this thing called a table in Lua. And really, tables are the only composite data structure in Lua. Lua does not have like arrays. It does not have anything else. It only has tables which function as dictionaries and arrays and all of the things that you would normally associate with a language as a set of composite data structures. Lua just has tables. And they serve their purpose as the general purpose data structure very nicely. So we're going to come down to love.draw, and we're going to get rid of this hello world print. We don't care about that anymore. And instead, we're going to use a brand new function called love.graphics.rectangle. Notice that when I hit parentheses in VS Code, because I have the Pixelbyte plugin installed, we actually see what arguments that function expects. It says mode, X, Y, width, height. So it's very convenient in that case. It gives us access to sort of behind the scenes, the entire API for Love2D. And if anybody is curious as to the Love2D API, even just beyond some of the functions we use and wants to see more information, you can go to the wiki on love2d.org. And then if you go over to the left-hand side on that next page, you'll see that there's a page for every single main sort of puzzle box that I just alluded to before, one of those being love.graphics. If you click on that, we can go down over to love.graphics, all these functions and data types, but there's love.graphics.rectangle right here. We can click on that and see lots of information on all of the arguments, what they're expected to be, the descriptions for them, what order they go in, different ways we can call these functions, examples of how to use the function sometimes, a very nice, robust set of documentation that I highly recommend folks explore. I'm just going to pass in the, it looks like Valerie already did, but just a reference to love.graphics. Oh, I sent that as a direct message to somebody. I apologize, but a reference to love.graphics.rectangle. Once you do that, or once you go to that website, you can freely explore at your heart's content if you want to see all of the wonderful widgets and whatnot that Love2D has to offer. It's quite extensive, but we are only going to be using a very small subset of all of this functionality today to at least whet folks' appetite. But suffice to say, we can use our Pixelbyte extension to get a sense of what the arguments are, even without going to the wiki. So knowing that it takes a mode, an X, a Y, a width, and a height, I'm going to say the mode should be fill, and I know it's fill because I've looked at the API documentation. It can be either fill or line. I'm going to pass in an X and a Y. Well, we have a player one that has an X now, player one dot X, dot being the operator to get a particular value out of a table. Player one dot Y as the next argument. And then the two constants we defined previously, which were paddle width and paddle height. Once we've done this and we run our code, you can indeed see at the top left of our screen here, located 10 pixels from the top left origin point, drawn relative to its top left corner. So all objects in Love2D by default are drawn by their top left corner. This is a very important thing to keep in mind. We have our first paddle shown there. I'll go ahead and quit that. I will take a look at the chat here to see how things are. And Valerie's kindly also posted a link to the repo. So yes, indeed, you can see the prior code from the last seminar and the two seminars before that to see, if you get behind or if you want to peek ahead. There's plenty of resources there, plenty of code there to check out. And this code that from this seminar will also be going out later this evening as well. All right. So in Lua, all the functions are automatically run. All of the love functions that we have here are automatically run. The love.draw, love.keypress, love.update, love.load. These particular functions are automatically run for us, but we have to trigger the other functions. For example, this love.graphics.setDefaultFilter. This is only run in love.load, for example. There are some functions that in the world of Love2D are just magically plugged into the right spot thanks to Love2D. But they're only a minority. They're only a small collection of functions. And they really are, we have already defined all of the functions that we care about that are love specific going forward. We will define a couple of our own functions in the future that we will trigger them, but these functions specifically are all automatically run by Love2D. Good question. Does the push function need to be installed? You need to make sure that you download it from GitHub and plug it into your live or into your folder, wherever it is on your computer that has your main.lua file located therein. All right. Just taking a look at everything. Okay. Fantastic. Okay. So hopefully folks are following along. Somebody's asking, what's love.update? Don't worry, we will get to love.update very soon. But before we do that, actually, I want to take a few minutes to request an exercise of the current viewers. We'll allocate 5 to 10 minutes here to essentially do what I just did for player one, but let's do it for player two. If we go over to the slide deck, you can see on the bottom right of the image here of the slide of the sort of screenshot of Pong, we have another paddle located at the bottom right, 10 pixels down away from the bottom right hand corner of the screen. So as an exercise, let's see if folks can maybe take a stab at drawing this onto the screen in much the same way that we did for the first paddle. And we'll be back in a few minutes to illustrate how to do so. If folks have any issues along the way, do post in the chat. But until then, good luck, have fun. I will be back in just a few. All right, hopefully folks had a relatively easy enough time with this challenge. If not, don't feel discouraged. It can be certainly a lot at first, especially if this is one of your first programming languages or your first foray into game programming. A lot of this stuff can feel very foreign. I was definitely there once myself, but we're going to go ahead and forge ahead with the player 2 implementation. So if we're looking at player 1 and we're trying to sort of imitate what we did there, we can just below it declare another table variable called player 2. And we'll just say within player 2, we want another x and y, just like we did previously. Only the x and the y for player 2 are obviously not going to be at the top left. They're going to be at the bottom right. So the x, we can say, should be equal to, let's say, virtual width, which is the far right side of the screen, minus 10. Now, considering that everything is drawn relative to its top left corner, and we want to accommodate this, we want to shift by the to the left from this position the width of the paddle as well, so that we are properly drawing it the equal distance from the bottom right as we are drawing the left paddle from the top left. And the same holds true if we do the x or the y here. We say y is equal to virtual height minus 10 minus the paddle height. Now, if you've written that out right here for player 2, you can then go down to your draw function, and below where we have the code, the rectangle call to draw player 1, we can just accordingly do the love graphics.rectangle call, which is almost a copy and paste really of the other line, but we'll say instead of player 1.x, it should be player 2.x. Instead of player 1.y, it should be player 2.y. But paddle width and paddle height are both going to be the same. And if we run this, following that, we'll have indeed the second paddle being drawn at the bottom right corner of the screen. So I hope folks were able to at least make progress in that direction. No worries if you weren't able to or weren't able to make it completely all the way there. It can certainly be a challenge, especially when being tasked to do so on a time limit, for sure. Let me just look at the code here, or sorry, the chat rather, just to see if there are any questions I can pluck off. If folks are having technical questions, we probably won't be able to allocate time explicitly in the seminar for that, but certainly do try to get mentor assistance or post on Ed, or do reread the instructions that CS50 posted for how to get it set up on your platform. And if Alt-L or the Pixelbyte plugin is not working, do just use manual dragging onto the Love executable for now, if that is the only available recourse. But my apologies if it is not presently working as smoothly as is desired. Now, folks are asking how to change the color of the rectangle. So we don't really get into that too much, technically speaking, but if folks did want to do that, we can say something like love.graphics.setColor, which is going to set a global color that we currently are using to draw to the screen. And because this isn't part of the technical official seminar, we'll kind of gloss over this a little bit, but we'll say 1001 for, and this is a minor spoiler for just a couple seconds from now, but essentially RGBA, if folks are familiar with RGBA color, this just means full red, no green, no blue, and full opacity, which folks might be able to guess means a fully red color. And if we run this, we'll indeed see that our Pong rectangles are not white anymore, which is the default color for drawing, but rather red. So that is how you change the color in Love 2D. We will not be doing it with anything besides white colored objects in the rest of the demonstration, the rest of the seminar, but we will use something called clear here for a particular reason. As I'm looking at this, I'm seeing, minus the red paddles now, which are kind of ominous. The background is a kind of harsh, pure black, and it can be a little hard on the eyes. Having sort of hard white on hard black can be a little bit too at odds with each other, so to speak. If you're looking at VS Code, for example, you can see they do not use either hard white or hard black for the text and background respectively. They're sort of shades of gray, which is a bit easier on the eyes. And we'll be doing something slightly similar to this. What we're going to want to do is there's a particular function. I'm going to go cheat a little bit and go into a prior seminar's code just to grab this particular line because I don't have the color values off the top of my memory. But we'll say, well, we'll paste this in here and we'll take a look at it. Essentially, we have love.graphics.clear, which is a function that basically clears the entire screen to a particular color. And the arguments that are being passed to this are a set of color values, much in the same way that we had in when we called love.graphics.setColor just a moment ago. And notice that they are also all divided by 255, which is kind of strange. The reason that they are divided by 255 is that these are all 8-bit values that can be from 0 to 255. And the result of us dividing, of course, by 255, given that the number can be between 0 and 255, is that this makes the number become from 0 to 1, which is the format that Love expects when we're dealing with colors, because long story short, it passes these numbers to a backend called OpenGL, which deals with floating point values that then do all kinds of crazy things to make graphical stuff happen on our computer. But suffice to say, it's easier to think in terms of RGB triplets as sort of whole numbers, at least for me, than just to think of the floating point value equivalents. In other words, for example, this might be something like 0.17 or whatnot, or 0.17253, you know, who knows? But it's easier for me to say, okay, I want 40 on the red, 45 on the green, and 52 on the blue, and then full opacity. In other words, basically 1, right, is the equivalent to this. And then I can use something like Photoshop or any number of tools that give me RGB values and just say that divided by 255 if I ever want to use a particular color value that I care about. Now, this is a color value that I picked from some screenshot of Pong that I looked at a long time ago that was a color that fit the bill, so to speak. So if I run this, you'll now notice that the background is no longer a harsh pure black, but rather some sort of bluish gray color, which is a little bit easier on the eyes. And do make sure that this is happening before anything else that you draw, because love.graphics.clear will completely wipe the screen and everything you've drawn to it thus far with the color that you've passed into it. So let me take a look at the chat here just very briefly. All right. So asking how to download main and push. So main is actually a file that you will create, main.lua, but push is available via a library, a GitHub repo that we were using. If anybody might be so kind as to post that in the chat. I don't have the link super handy at the moment. But essentially, if you grab that off GitHub, put the push.lua file located therein within your folder that you should have with the main.lua, you'll be able to then require push in the in that project. And thanks to Kylie for posting the source code and Cayenne for posting the source code for push. Much appreciated. So we now have color being printed to the screen, or rather a better background being sort of cleared on the screen. And we've talked about color, we've talked about RGBA and how to normalize it between the values of 0 and 1 to work with Love 2D, which is a very important thing to know. Let's now take some time to talk about the last missing piece of our game loop. So if we go back to our slides, we can see that we have the input, which we are taking care of already with love.keyPressed. And not to say that that's the end of the picture, but certainly a piece of it. And we have render, which we're taking care of with love.draw thus far. The last piece of the puzzle is this thing called update, right? An update function, which we have already written. But this is really where the meat of the game exists, where a lot of the state gets changed and manipulated, things get tested, things move around. That all usually happens in the update function, where the bulk of the logic is, where most of your processing is going to take place, unless you're doing crazy graphical stuff, in which case maybe the render will be where a lot of your loop or a lot of your frame time gets spent. But let's go back to the code here and let's focus on our love.update function that we've had here this whole time, which has been empty. And think about it for a second. So love.update is another function that Love2D is going to look at and say, okay, I see you have a love.update function. I'm going to call this update function every frame, and I'm going to pass in to that update function dt, delta time, the delta between this frame and the last frame, the difference, in other words, in seconds, which means that if we're thinking about 1/60th of a second being a frame's duration, then we're thinking in terms of something like 0.013 or the like seconds per, if we have a consistent frame rate of 60 frames per second, that's what we could expect delta time to sort of be. And that this value is really the crutch that will allow us to essentially make sure that our games behave the same across all computers, no matter how strong or weak your computer system might be. If we have delta time, we can move things the same distance because we can just multiply any operation by delta time, and it will move the same distance between any two chunks of time, whether 10 frames have passed or whether 1 frame has passed, right? So knowing this, why don't we actually move the paddle. Let's start actually moving, being able to move our top left paddle using the keyboard. Now, the catch is, we've been using love.keyPress this whole time, but love.keyPress is only really intended to be used immediately on the one frame that you press down a key on the keyboard. And then no matter how long you hold that key down thereafter, it's not going to keep sending that key pressed event, so to speak. It's only going to do it for the one frame. So it's great for button presses to get through menus and to make decisions, but it's not so great to hold down buttons to be able to move continuously across the screen. So in order to do this, we're actually going to have to use a different function located within the love.keyboard namespace or puzzle box or Lego box, so to speak. So Valerie posted delta timing, a Wikipedia article to the chat there. Folks want to take a look at that and maybe see a more technical illustration of why it's important and why we use it. Why is push required? It's not required per se, but we use it to draw to a resolution that more closely mirrors that of something like Pong from back in the day, or an NES game or a Super Nintendo game. It's an aesthetic decision, not a technical decision. But good question. All right. So just looking through the chat. Folks are kindly also presenting more elaboration on some of the things that I've said. So that's also super great. I appreciate all the work the mentors and volunteers are doing. You guys make my life a lot easier. So thank all of you for your kind assistance. All right, let's transition into thinking about moving the paddle. So we know that we want to hold a key down on the keyboard to move a paddle up and down. And we need to know basically then, okay, well, we want to move the paddle, but how fast do we move the paddle? Well, let's define another constant, and let's think in terms of pixels per second. Let's think about maybe something like paddle speed, and let's say let's make it 140 pixels a second. So in the space of 1 second, if we're holding down W or S, if we're assuming WASD movement, the paddle will move 140 pixels either up or down if we're pressing the same direction. Down in love.update, what we can now do is we can say, okay, so we know this is going to be called every single frame. If love.keyboard.isDown, this is a utility function in the love.keyboard namespace or puzzle box, and we'll pass in a string. We'll say W, takes in the different keys on your keyboard as strings, just like the love.keyPressed key parameter here is going to be a string. It's the same set of key codes here. If love.keyboard.isDown W, then, and do note the then as well. Anytime we do an if statement, there needs to be a then that then matches up with an end. This is how we do blocks of logic in Lua. So if love.keyboard.isDown W, well, we'll say player1 dot y, because we're going to move on the y-axis, and we only want to move on the y-axis. That's how Pong works. We're limited to moving only vertically, not horizontally. We'll say player1 dot y gets player1 dot y minus paddle speed, but not just raw paddle speed, because if we were to do this every frame, paddle speed's 140 pixels. If we executed this, remember, every 1/60th of a second, this is going to move 140 times 60 in the span of a second. What we want to do is we want to multiply paddle speed by delta time, which, remember, Love2D is going to pass in here for us to tell us how much time has passed since the last frame, and we move by that amount. So if assuming we move at a consistent frame rate of 1/60 frames per second, or rather 1 frame, 1/60 frames per second. Sorry, if we move 60 frames per second, if we're moving 1/60th of a frame right now, 1/60th of a second, a single frame, I'm getting my words all mixed up, I apologize. Essentially, delta time will be equivalent to 1/60 if we're assuming a consistent 60 frame rate, 60 frames per second. 30 frames per second, you'll be looking at double that. You'll be looking at 0.02666, I believe, something like that. But no matter what this amount is, no matter how many frames have passed, assuming that there have, if there's been a hiccup and your machine slowed down and maybe 10 frames got skipped, then 10/60 will be the value here, and we'll be multiplying by 10/60. No matter what, we're normalizing the difference that we're moving, no matter how many frames get dropped or not, which allows us then to consistently move things across different computers. Even if one might be moving slowly and one might be moving really jagged, because it's just not able to keep up due to system limitations. Equivalently, we'll add to this if statement here an else if, right? If we're not pressing W, but let's say we're pressing the S key, right? Then what we want to do is do the same thing. Player1.y gets player1.y, but we're going to add paddle speed dot delta time, because do recall that positive y values move downwards on the y-axis and negative y values move upwards. So if we're subtracting a value, we'll go up, and if we're adding a value, we'll go down. So assuming all of that is correctly implemented, now we run the code here, and I press W or S right now, we do indeed see that the paddle is able to move up and down on the screen. So it's a big, big jump, a big improvement. We're actually close to the completing all of the input code for the game, at least conceptually. So this is a pretty big deal. All right, just looking at the chat here, just very briefly, making sure we're all caught up. Does Lua follow BODMAS? I'm actually not sure what that acronym stands for off the top of my head. If you could elucidate that one for me. Reminds me of resource initialization is allocation, if that's the right acronym, RIIA. I might have that mixed around somewhere. It's a C++ thing. Okay. Oh, I see. Brackets. Oh, I see. So PEMDAS. Yes, yes. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. I've never heard of the brackets of division multiplication. That's interesting. Yeah, so yeah, it follows the traditional rules of arithmetic for most programming languages that I've at least worked with, which is that multiplication and division occur before addition and subtraction, left to right, and before all of that takes place, parentheses get evaluated. So good question though, absolutely. Let's go ahead and take a few minutes now. So we've written out the code here for how in the update function to get the input down, whether we're actively holding down W or S to move player 1. Let's do the equivalent now, but for player 2, and let's make it an exercise for the viewer. So let's take about 5 to 10 minutes here. It's going to be relatively similar to this, but of course now instead of W and S, let's talk about, or let's implement maybe how this could work for, let's say, the up and down keys on the keyboard to be player 2. So let's take a few minutes here, and then we'll be back in just a few. All right, hope folks had an okay time with that one. So we're gonna go ahead now and implement. So the task was, currently we have the player 1 able to move using W and S, but we would also like player 2 on the bottom right to be able to move with up and down. So why don't we do that? So in a separate if block in love.update, what I'm going to do is I'm going to say if love.keyboard.isDown up, literally the string up, which thankfully love2d is fairly intuitive when it comes to their keys. Love.keyboard.isDown being the other part of that condition. I almost typed right instead of down for some reason. So notice that we're saying if love.keyboard.isDown up or down, just in the same way that we did up here. What we're going to do is we're going to do the same logic that we did previously. We're going to say player2.y gets player2.y minus the, minus paddle speed times delta time. So very similar. We're just basically changing the 1 for a 2 there. And the same thing holds for the other line of code. So now we have player2.y gets player2.y plus paddle speed times delta time. And unfortunately, Lua does not support composite assignment or combined assignment, or however the terminology gets used, where we could do player1.y plus equals paddle speed times delta time, or minus equals paddle speed times delta time. That's unfortunately not a feature of the language. Lua does require you to explicitly assign variables to themselves in operations if you do. So an unfortunate shortcoming of the language, which folks might feel spoiled coming from Python or JavaScript or even C or other languages. It also doesn't have, for example, the plus plus operator, but it is something that you do feel comfortable with eventually, and you don't think about it so much over time, but it can be one of those initial sort of unfortunate sticking points. Andrew's asking, does white space matter in Lua? It does not matter in Lua. White space is not, it is not like Python where it's semantically relevant. Using these then and else if and ends are how you sort of denote blocks in Lua, such that it doesn't care about white space as long as you have the matching syntax to denote blocks. So if you had written that code out and you save and you rerun, all should be well in the world. And I can indeed move both paddles here at the same time. Somebody had mentioned that they were unable to move both paddles at the same time. And to that, I would probably suggest making sure that you don't have if, else, if, and then 2 more else ifs following that for the up and down, because in that case, then in the event that you're pressing one key, it's mutually exclusive to all of the other keys. So do make sure that these are 2 separate blocks. And somebody else also suggested, well, maybe these shouldn't be even if, else, ifs anyway at all, because currently if we were to press W and S down at the same time, the W takes precedence being a faster check than the S, which means that we will always move up if we press both keys and always move, or if we press W and S, and then the same thing is true for up and down. And to that, I would say certainly you could do it in 2 separate if statements. That might actually be a better design, but that's a decision that you will have to make as a designer when it comes to your game engine, because some games, if you're playing around and you're testing things out and you're testing button combinations, they might sometimes behave in ways that you don't expect. And sometimes having a default direction or a default behavior, even when 2 things happen at once, is actually deliberate or a goal of the designer. But that's going to be up to you. For our purposes here, we're going to not worry about that as much and just put them in if, else, ifs, but just know that you could do either one of those. All right. Gerard's asking, I wonder if you can hook up a game controller into a Lua program. As far as I understand, you can. Certainly, they do have a joystick namespace, I do believe. Yeah, love.joystick, which is up here. So this should have all of the functions necessary for you to plug in a controller and get access to it. Now you might need drivers for your computer depending on what controller you're using. If you're using an Xbox One controller, usually those work just sort of out of the box, but other controllers, for example, at least historically, things like the older PlayStation controllers would need drivers, specific drivers for them. These days, you might be able to just plug in a controller and have it work out of the box, but I have not tested in a long time to see how controllers are faring these days, cross-platform wise. So that is the code for making the other player move. So the next step that I think is relevant is we have both paddles moving now, but we don't have a ball. And the ball is kind of the main last big piece of the environment that we need to get running. So why don't we now transition into getting the ball sort of moving or rolling, sort of to use a corny joke. Can we use a PlayStation in Lua? Asks Ashite. I'm assuming that you're asking, can we use Love2D to program for PlayStation? In which case, I'm not sure. Probably there's somebody who has made a port of Love 2D for PlayStation, because at least PlayStation 4 was x86 architecture, and it was probably relatively straightforward. If I remember correctly, someone had done so for the Switch, and if they did it for the Switch, chances are they probably did it for PlayStation as well. I haven't dug too deep in to see if that's the case or not, but it seems to me like it would be fairly feasible and straightforward to do so, as long as you have a license to, of course, compile and program for the architectures in question. She's asking, should we make a barrier for the paddles? Now, I had talked to somebody in chat about this, but you absolutely could and should, in a final implementation, make a barrier for the paddles so that they don't move beyond the top and bottom edges of the screen. For the sake of this seminar, we don't talk about that. We do cover that in GD50's first Pong lecture, which is the course that I teach. We cover how to set up clamping on the y-axis for both paddles to make sure they don't go above and beyond the top and bottom edges of the screen, but do try to maybe tackle that as an exercise if curious. It would essentially involve making sure that you don't go beyond 0 on the top of the screen, or the paddles width beyond the, or paddles where basically the bottom of the screen minus paddle width on the y-axis, or paddle height on the y-axis rather. So let's go and let's start implementing the ball. So I can essentially think of it kind of in terms of the way I've thought of player 1 and 2, in that it is a rectangle, albeit it's going to be a square rectangle. So we'll define another ball table, or another table called ball in this case. We'll give it an X and a Y, and I want to start the ball right in the dead center of the arena, so to speak. So to do this, I can just say X is equal to virtual width divided by 2. Now remember, everything's drawn relative to its top left corner, so it's not actually going to draw it centered perfectly. It's going to draw it slightly to the right, 2 pixels to the right, if we assume our ball is maybe 4 pixels in size. And to go along with that real quick, why don't we add another constant to say just that? We'll say ball size gets 4. So now we have a 4 pixel ball size there. So we'll say X should be equal to virtual width divided by 2, so half the screen space, and then minus ball size divided by 2, which will have the effect of drawing the left half of it and the right half of it over the left and right edge of the center line dividing the screen effectively. And we'll do the same thing for the y-axis, but instead of virtual width, of course, we'll use virtual height. So we'll say virtual height divided by 2 minus ball size divided by 2, just like so. And just like we've done for the paddles, we scroll down to our love.draw. It's just going to be another function like we've seen before, love.graphics.rectangle, takes in fill, takes in not a player this time, but ball.x, ball.y, and then ball size for both the width and the height here. So if we do this and we run the program, we'll see that we do indeed have a ball printed right in the dead center of the screen, just where we want it to be. Okay. Some people are taking a stab at the clamping of the Y value, which is, it's great. That's how you obviously improve and expand your skills. So do feel more than free to try to tackle exercises like that. Somebody asked me to go back up to ball size, so here we are. We're at the ball size sort of declaration. The ball size gets 4. It's a constant. It's not going to change, just like everything else that's up here. And then ball, of course, is a table, just like player 1 and player 2. And then, of course, the rectangle call, which folks probably are getting pretty familiar with now, just the love.graphics.rectangle fill with the sort of ball arguments there. All right. Fantastic. Okay. So we have the ball. Now it's static. It's not really doing anything, so it's not particularly interesting. So to remedy this, we need to think about how our ball should move. Now with our paddle, we sort of have been implicitly dealing with velocity, a constant velocity. And velocity is going to be constant for the ball as well. But the ball can move not just on the y-axis, but rather it can move in any really direction, or at least it should be able to move in any direction, whether that's diagonally up to the top right or to the bottom left or what have you. We essentially need a way to give it a velocity, not just on the y-axis, but on the x-axis as well. And then by sort of adding these velocities together, by performing an addition on the y and the x of the ball, given its velocity on the x-axis and velocity on the y-axis, this will produce the result of us moving in various different directions. Whether the velocities are negative or positive will influence whether they are left to right, top to bottom. So the first step for this is why don't we just declare these velocities and we'll include them as part of the balls table. So we'll say dx for delta x should get 0. So currently still static, not going to be moving. Delta y gets 0, so still static, not moving. Now, to make the game interesting, and this is very common across all games, no matter what you're doing, we don't want the ball to obviously start with a constant velocity that's the same every single time. We want the velocity to be sort of randomly, dynamically generated. And to do this, we're going to need to use what's called a random number generator, RNG, which you've probably heard of or seen in reference to various games or game engines. Or maybe you've heard of folks manipulating the RNG to suit their own purposes. In Love2D, we completely do have access to it. Really, rather even in Lua, this is just a regular Lua feature, is that we have this ability to generate random numbers that we can then plug into our game. But in order to do this, we're going to have to do what's called seeding the random number generator. Now, what this means is that, as some folks may know, may or may not know, random numbers aren't actually random in the world of computer science. There is no such thing as a truly random number because computers are deterministic machines. Given an electrical input, they will produce a constantly reliable electrical output. Now, the thing about random numbers is that we want them to sort of feel random. So random number generator will sort of give us the illusion of feeling like the numbers are random. They'll be all over the place, but they are pseudo-random. They are programmatically generated by some algorithm that sophisticatedly, don't know if that is a word, but that sort of in it with a complicated algorithm, we can generate a very sort of believable set of random numbers. Now, the way that we get by with making sure that this actually is different every time we run our program, even knowing that random number generators aren't really random, is that we provide an initial sort of non-reliable number, or it's always never known number, to our RNG, our random number generator. And in particular, we're going to use our system time, our current system time in milliseconds, which is always going to be some big number that's always going to be different no matter when we run our program. So to do this, in our love.load function, right at the very beginning, we're going to say math dot, and math is a Lua namespace or a Lua puzzle box. It's not something that belongs to Love2D, but this is something that Lua itself actually has, the language. We'll say math.random seed. So we're going to seed the random number generator, and it expects a value, and this value is going to be os.time, which is the parentheses here signify that that's a function call. So we have os.time, which is going to be our current time in milliseconds, which is given to us by our operating system, OS being another Lua specific or a belonging to Lua sort of namespace or set of functions that we pass into math.random seed. And from henceforth, we can now say something like, okay, I want to initialize a random x and y velocity on the ball. So to do that, I'll just say ball.dx should be equal to math.random, and we'll just say some value between 1 and 60. So math.random expects a value, and if you give it a number, it'll give you a random number between 1 and that number. So in this case, ball.dx could be anywhere from 1 to 60. So very slow or relatively fast, if we're assuming pixels per second, just like we did with paddle speed previously. And the same thing true for our dy. So ball.dy should be equal to math.random 60 as well. Now, one thing you might be thinking or noticing already is that if it's between 1 and 60, well, these numbers are always going to be positive, which means that no matter what we do, this vector, no matter what the numbers are, it's always going to be sort of down and to the right because, positive x, positive y, right? It's always going to be going straight down and to the right. In order to mitigate this, in order to make it actually random, we have to make sure that we can have negative velocities as well, so that we could go up and to the left, or potentially any combination of those possibilities. So to do this, we'll use random number generation for another cool thing, which is to effectively flip a coin. So we'll say if math.random2, which is going to give us between 1 and 2, which could be, it's effectively the equivalent of flipping a coin for heads or tails. We'll say if math.random2 is equal to 1, right? So it could be either of the values. So we'll just say, okay, if it's 1, if it's heads, then ball.dx is going to be equal to negative ball.dx. We have a 1 in 2 chance, a 50% chance to just negate whatever our dx is that we just generated. And we're going to do the same exact thing here for our dy. If math.random is equal to 2, well, then we'll just say ball.dy is equal to negative ball.dy. And what this is going to do is it's going to just give us between 1 to 60, and then it's going to coin flip, negate them. So we could get vectors going in all sorts of different directions on the screen that our ball is going to move. And it'll feel every time we start the game like it's a fresh new gaming experience. And this is why random number generators are super useful and why they are ubiquitous across games, no matter what you're playing. If you want something that's not super boring and predictable, rather. So let me take a look at the chat here for just a second. 60 of what, asks Big Dawes. So 60 is just going to be just a random number between 1 and 60. That's what the 60 is for. They pass in a math out random. We want to just give this ball.dx a random velocity, and we don't care necessarily what it is as long as it's random and it's between 1 and 60. Now, for right now, this is really slow, as we'll see in a second, between 1 and 60. It could be 1 in both directions, in which case, if it is, well, the ball is going to take forever. It's going to move 1 pixel a second. It's going to take ages to get to the left or the right side of the screen, potentially 2 minutes. So we're going to want a way to negate that, which we'll take a look at. Gabriel asks, why are you calling the randomize with os.time? Because that's the most reliable way for us to get a random number on the computer to seed our random number generator. We know that that's going to be different every single time. It's going to be a really big number. We can reliably use that every time we restart the game to seed our random number generator. There's a typo on line 24. Is there a typo on line 24? Hopefully there isn't, but if there is, I will definitely see it when we run the game and we get a blue screen of death. All right. Where are we using the number, asked Gabriel. Oh, well, it's funny you asked that, because we are actually just about to get into that. So I can tell that you're paying attention. What is the difference between dot and colon? It's a complicated topic for a seminar like this, which is kind of aimed at folks less comfy, but essentially it lets us do object-oriented programming in Lua, or at least a version thereof, very similar to the way JavaScript does functional object-oriented programming. There are these thing called there's a thing called a meta table that objects have, which allows them to sort of produce copies of themselves and then reference a what's called a prototype, or that in effect the prototype is a meta table. And then you can do fancy stuff with copies of objects, essentially copies of tables. If you have a bunch of, if you wanted to have maybe 100 balls or paddles in your game, you could use meta tables to accomplish this. But we are not going to dive too much into that. But push is implemented such that it has a meta table associated with it to allow you to call methods on an object that you load into your game and call it push. And so therefore we need to use colon in order to get it to work properly. But no need to worry about the technical details of how that works. You can, if you desire, you can go to the Lua reference manual, which is here. I'm going to post a link in the chat where you can talk about a little bit, or you can read about a little bit more in terms of the different Lua features beyond just the basics that we talk about today. Whether you want to get deeper into loops or into meta tables, meta methods, different language features. The Lua programming manual is a very robust resource. I mean, much the same way that the Love2D documentation is very good. The Lua programming manual has lots of examples and elaboration on a lot of stuff that we're sort of glossing over in some aspects today. But do feel more than free to browse that if curious. All right, let me make sure that I haven't missed anything. What does random seed do? Random seed gives an initial starting value to the random number generator that makes sure that it's different every time we rerun the application, essentially. Because if we don't seed the random number generator, it's going to give us the same values, the same random values every single time we run the game. Because again, there is no such thing as random numbers. They are just programmatically generated. So given the same initial starting conditions, we'll always get the exact same subsequent computed values. So we need to seed that random number generator to be different every single time. Good question. All right. Somebody astutely noted that we aren't actually doing anything with our delta X and delta Y on the ball. So why don't we go into our love.update function and go to the end, sort of after we have dealt with the input side here. Now, anything that sort of deals with movement, recall, sort of belongs in update, because we are, trying to account for things that move and multiply those values by delta time. This is a perfect use case for the update function. So in love.update, what we want to do is basically say ball.x is equal to ball.x plus the ball.dx times delta time. Now this takes that velocity, which could be between 1 and 60 currently. And remember, we don't want to move 60 pixels per frame because that's 3,600 pixels over the course of a second, right? Which is way bigger than the size of our screen. We want to multiply anytime we move by something by delta time, so it scales it down to the appropriate pixels per second value, such that it behaves consistently also across platforms. So do remember to multiply by delta time, or you will experience things moving way faster than they should. And we're going to do the same thing with ball.y. We're using ball.dx and ball.dy to move the ball by adjusting its x and its y. So the velocity gets applied to the x and the y. So we'll add ball.dy multiplying by delta time. Now when we launch the game, we'll see that we have an initial velocity and the ball should move on its own. And indeed it is. It is moving to the right and down, which means that it was given a positive x value and a positive y value and relatively high values because it moved pretty quickly. Let's rerun it. Let's see where it moves this time. Notice that it's moving slower this time. It's moving to the left and down, which means that it's moving negative on the x-axis and very slowly positive on the y-axis. So the dy in this case was a lot smaller than the dx was. Absolute value-wise, it was smaller. And so one more time, just for good measure, down, and notice the steep sort of y level. So moving slowly on x, but fast on the y. So a steep sort of downward trajectory. So it's different every single time we run our game. And the slope is also different because we're adding together a dy and a dx that could be between 1 and 60, negative or positive. Now, I had mentioned previously that I didn't like the fact that it could potentially be theoretically as slow as 1. We could get almost no movement on a particular axis. And the way that I like to remedy this is actually just give us a baseline value before we add that random value to ball.dx. And let's just say it should be 60. We'll start at 60 and we'll add a random value between 1 and 60, and then we have a chance to negate that. Accordingly, on the y, let's start with 30 because our vertical sort of space is smaller, so additions to the vertical movement will feel much faster than additions to the horizontal movement. So let's just add 30 to the delta y and save, and then rerun this. And now every time we run this, it should be pretty consistently fast, sometimes faster than others. So that's pretty fast. How about this time? That time it moved in basically the same direction. Let's try it again. Moved in about the same direction again. Let's try again. A little bit less steep that time, so a little bit above, but both positive values. That time moving up and to the right and a little slower. So you can, it felt random. We got 3 times where it was almost in the same direction, one slightly less steep slope than the other 2. But it doesn't feel sort of like we're being distributed uniformly. It kind of, sometimes you'll get a few in the same direction, and that's to be expected. We want this to feel random. We don't want this to feel maybe architected in a particular way. That would involve a bit more tuning if you wanted it to feel that way. And that gets into more of the concept of the territory of game design. But for right now, for the sake of what we've coded, we want this to basically just be purely random, which we have accomplished. All right. So just looking at the chat really fast. Xin Wen has kindly posted the difference between Math Random and Math Random Seed in Lua, which is super helpful. And Stack Overflow is an awesome resource. So folks, do definitely check out Stack Overflow, whether you're doing game dev or other dev or web or whatever. It's a super useful resource. A lot of problems have been solved many hundreds, if not thousands, if not millions of times by other developers across the world. And there's plenty of knowledge to be found on resources like Stack Overflow and elsewhere. So this is great. We now have movement of the ball. It's random. We've gotten familiar with using random number generation, which is super important. The thing that I don't love is the fact that we essentially just immediately start in like go fast mode when we start the game up. It's just boom, we're going, and the game is started, right? Ideally, we should have some sort of maybe title screen or some sort of screen to serve the ball in between in between the ball hitting the left or the right edge of the screen. And additionally, we need a way to check that the ball has actually hit the left or the right edge of the screen so that we can assign a point to player 1 or player 2 and then go back to that serve state. And these are two pieces that we are going to plug in now. Why don't we tackle the title state first? So in order to do so, let's go back to my slide deck here. So I can show all of you a slide that presents the concept of a state machine. Now, state machines are really important in computer science, generally speaking, but in games in particular, they have a special purpose. That is to not only manage the state of things like characters, enemies, and so on and so forth, but also our game state, which is what state our game is currently in. It's a sort of a self-explanatory term that may not make 100% sense right off the gate, but effectively our game is always in one state at a time. We can either be at the title screen or at the pause menu or at we're playing the game or we're at the game over screen. These are all different states of existence for our game, and entities, players and characters and basically anything that can move around and do different behavior also typically has a state machine associated with it. Now, this diagram is for something like Mario in a platforming game, right? We have a set of states. The states are these boxes, right? A standing state, a jumping state, diving and ducking. And then there are also these things called state transitions, these arrows, which have a description. For example, going from the standing state to the jumping state, we have an arrow that says press B, which signifies that when we press B, we should transition from the standing state to the jumping state, at which point we will now be in the jumping state and we can perform any actions that will allow us to transition to other states. So if I am standing and I press B and I go to the jumping state, I can then press down, as we can see there, to go into the diving state, right? If I'm in the standing state, and let's say I press down instead of I press B, well, I'm taking that transition to the ducking state, at which point my character is now ducking, and my only recourse is to release down, at which point I go back to the standing state. So we have this sort of loop of a looping section of the state machine right here, which our game will also have a looping section going forward. But you can sort of visualize our game as a set of states too. If we're thinking of the title state, and let's say the title says to press enter, we press enter. And then we go to a serve state where it said, okay, now it's time to serve the ball, press enter to serve the ball. We're in the serve state, we press enter. Now we're transitioning into the play state where the ball's moving now and we can score on each other and the ball can collide. And if the ball hits an edge, either the left or the right side of the screen, well, now we should trigger a state transition back to the serve state, right? After we add, of course, a point to either player 1 or 2. And then once player 1 or 2 reaches a certain point cap, let's say 10 points, then that's another state transition that takes us to, let's say, the game over screen, at which point the scores get restored to 0. And if we press enter, then we go back to the title screen, at which point everything's come full circle and we have a complete cyclical state machine for our game to describe all of the possible game states. And we're going to be implementing most of this actually going forward using relatively simple mechanics. Let me just check the chat here, see if there's any questions before we forge ahead. Folks are debugging plenty of codes, which I'm happy to see. Folks are working hard, clearly at adding some functionality too. So the code is on GitHub, Jabril, and it looks like Valerie's kindly posted a link there to show you how to get the slide source code and further instructions. An equal sign error. That I'm not as sure off the top of my head. You'd have to probably post a maybe some contextual code there so folks can see, since that could be any number of errors. But thank you to the mentors who are looking at chat, who are debugging. It is much appreciated. Now let's at least implement the title state, right? So if we look back at our slides and I come back up a little bit here, you can see that this is the title screen effectively. It doesn't say that it's the title screen state, but it is the title screen. We have a title here at the top. We have text here in the center, which we also need to implement. And then we have text here at the bottom, which gives us instructions. And instructions are always a good thing. You want to have that available to let the users know, how do I get from this state to another state? Well, they got to know, okay, well, press enter to go to the serve state in this case. So I'm going to start the very basics of this sort of state management by declaring a variable called game state. We're doing this in very simple terms. We're literally just going to use a variable and we're going to give it a string. And the string is just going to start with the value title. Game state equals title. Now, of course, as you can imagine, future states will have names such as play and serve and what have you. But we're just literally using a string value for now, and this can get more robust. And in GD50, if you take it, we use a much more robust system for state management. But just to illustrate everything, since states are effectively a set of conditions and conditional logic, we'll use a variable for to accomplish this. Now, the important thing is that when we're in the title state, the first thing we can start off with, when we're in the title state, the ball shouldn't move. It should stay in the center. If you recall on the slide, the ball's static right there, and it stays static until somebody presses enter. So what we need to do is basically need to say, okay, well, the ball shouldn't always move. The ball should only move when we're, let's say, if the game state is equal to play, only then should the ball be moved relative to its velocities, right? And if we do this and we run this already, well, we'll see the ball does exactly that. It stays right in the center of the screen. Now, there's not enough output to show us that we're in the title screen. So this is not really intuitive as to what's going on. Somebody might think the game's bugged at this point, which is why UI is a super important thing. But we're at least now capable, depending on what we set game state to conditionally perform different things in our code base. So accordingly, we should make it clear that we're in the title state. So to do this, I want to draw a nice big font in the center top of the screen that says, pre-50 Pong or what have you, whatever title you want to use. Now, by default, when we've been printing, we've been seeing that the font is, kind of on the small side. It's larger now than it was before, but it's still not quite as big as we want it to be. In order to do this, we actually need to have multiple fonts that we can work with. And this is actually really easy in Lua by default. We'll just say up at the top where we define all of our constants, our fonts are going to be constants too. We're not going to change them. They're going to be these objects that contain the data necessary to draw text, but they themselves don't change. So we'll just say, for example, large font gets love.graphics.new font. And we're going to pass in an argument that tells it how big the font should be. So 32 pixels large. And by default, this is Arial. But if you wanted to, or I believe it's Arial, but if you wanted to say pass in your own font, you have that option as well. You could say, my font.ttf, wherever this may be, whatever this font may be called, if you have your own font, you could certainly do this. And Love will create a font object based on the size that you pass in as the second parameter, given that font file. We will not do that in this seminar, but you could certainly go to defont.com or many other websites to achieve this if you would like. See GD50 for more on that. We accordingly need to create a small font object because we're going to want to revert back to the small font after we've used the large font. So we'll just make that half the size. We'll make that 16. And by default, I believe the font that we start with is 14 size in Love 2D, but I'm not 100% sure on that. I have to read the documentation for that. And again, if you wanted to find out more about these functions, you could, of course, look at the love.graphics namespace on the wiki to see more about the functions therein, and including functions like new font. Now we have the font objects. We of course have to use them. They don't do anything on their own. So way down below in the love.draw function, let's say before we draw the actual paddles in the ball, let's say, okay, well, we don't want to always draw the title, but let's say if the game state is equal to title, right? We're in the title screen, and only then let's love.graphics.set font. So let's set the current font that Love2D is using to draw stuff to the large font. And then we're going to use a new function called love.graphics.printf. So this is a useful function. As you can see there in my VS Code, it's telling me what the expected parameters are. You'll recall we used love.graphics.print, which just took in text and an X and a Y. Love.graphics.printf takes in a text, X and a Y, but also takes these two parameters, limit and align. Now limit, I think of as sort of like the column size. We think of like, if we were trying to center text on the screen, well, I want to, decide, okay, if I choose the game window as my column, I know that I can center it. If printf expects a column size that will perfectly center text within that column, I'll just make the limit, in other words, my entire screen, my virtual width, which will have the effect of centering it on the screen. You could set the column to whatever size you want, and it will just center it within that column. So if you wanted to center it on the left side of the screen, you could do that. If you wanted to split your window into two columns, you could have a left and a right if you were doing something like an article style format. But let's just center it across the entire screen. So let's say I want to write pre-50 Pong at the very top using the big font. I'm going to start it at the left at 0, because if you're using the column size as the window, you need to also start at 0 so it appropriately uses the entire window starting at the left edge. Otherwise, it will start the column based on wherever you set X to, which won't center it in the middle of the window. It'll center it relative to your offset, which is not good. And let's say I want it 10 pixels from the top. And again, I want to create that column size that I center the text in, which is virtual width. And then lastly, I have to tell it what alignment mode do I want to do? Do I want to left justify? Do I want to center? Do I want to right justify? Well, I want to center in this case because I want it to be centered right in the middle of the screen. And then last thing I want to do is I want to revert to the small font. Now, additionally, I also probably want to draw that prompt at the bottom of the screen to say, okay, well, you're at the title screen, but we need some instructions. Let's press enter, right, to continue on. Give the user a little bit of guidance, so to speak. So we'll just do another call to love.graphics.printf, only now we're using the small font, not the big font. But it doesn't matter because printf is smart enough to know that whatever font we're using, well, it knows how to center it perfectly. Just make sure you use the virtual width as your column size and center alignment mode. So if I do the same thing, if I say press enter, start at 0, but instead of 10 pixels from the top, let's say I maybe go 32 pixels from the bottom. So let's say maybe virtual height minus 32, making sure virtual width is the column size, and then I center it. This will have the effect now of a large font centered on the top that says pre-50 Pong, and then the smaller font on the bottom centered that says press enter. And if I run this, assuming I did everything correctly, we indeed do see pre-50 Pong being rendered right in the middle of the screen, top and bottom, large and small. We're missing the scores in the center of the screen, which we'll probably want to add very shortly here. But this is how you get to use centered text alignment in Love2D relatively painlessly. Anytime you want to center it relative to the screen, just making sure that you use 0 as your X and virtual width as your column size. And then Y can be wherever vertically you want the text to fall on the window. All right, just gonna look at the chat here very briefly. All right. Lots of debugging, which is good. I'm happy to see people are active. Super great. Okay. Scroll back down. What keeps the ball from exiting the screen through the top or the bottom? And then Maria astutely notes that will be covered later on, I believe. And that's correct. We will be covering exactly how to do that, how to cover collision detection with the paddles, and how to detect when the left or the right edge of the screen has been passed. Those are coming up actually very shortly. So good observation. Now, the catch to all of this is, of course, that we have the ability to draw to show that we're on the title screen, but we don't actually have a way to get out of the title screen, right? If we press enter, we could press enter all day. Nothing's going to change. Nothing's happening because I don't have anything checking for that input step. Remember, we need to check for input to do all of the sort of behaviors that maybe we take for granted when we're playing games ourselves. But fortunately, this is an easy thing to add on. If we remember back to love.keyPressed, which will handle these sort of key press events, because this is just something that I want to happen on the one frame I press it, it doesn't matter whether I'm holding the key down or not. It goes in the love.keyPressed function, right? And we just do the same thing that we did for escape. We just say if key is equal to enter or key is equal to return. And this is an example of where Mac will differ from PC in that Mac's default key for where enter is the return code. If it's equal to enter or it's equal to return, well, we'll just set the game state equal to play. Let's run this. So recall that we're in the title screen, and when we're in play, we have logic set to move the ball. So if everything goes according to plan, as soon as I press enter, not only will the text vanish, but the ball will start moving. It has its delta X and delta Y ready to go. So I'll press enter, and indeed the ball is moving down to the left at a randomly decided vector. So now we have the ability to transition between game states and the ability to draw centered text to better build a cleaner UI for our game. So of course that's going from the title screen to the play screen or play state. But as I alluded to before, we're going to also want perhaps a serve state, right, to give us a breather before the game begins, and also to give us a breather in between points. Because when we score a point on player 1 or 2, well, we kind of want to wait a second to before the ball starts moving again. Otherwise, we might get caught off guard. We might get frustrated. Let's give us a chance to sort of center ourselves and then get ready for the ball wherever it may go, wherever its vector may be. And in relation to that too, we need to reset its vector. We don't want to give it the same vector every single time, or otherwise the game is going to be the same every single time. It's going to be predictable. We basically want to reinitialize that vector, the two starting velocities, the dx and dy. So we need to take that into consideration as well. So before we even do that though, why don't we go and transition into checking for the left and the right side of the screen being detected. And in that, actually, I think, yeah, a better order might be instead to, what's a better order here? I think serve state. Let's do serve state first. So I'm going to describe what the serve state should be. This will make sense, I think, in a little bit as to why we do this before we go into collision detection for the left and the right side of the screen. There's either a toss-up between let's check for the left or the right screen and allocate a point, or cover the serve state. Let's cover the serve state first. The serve state I'm going to describe, and I'm actually going to leave it to you all to implement. So the serve state, the purpose, recall, of the serve state is to give us a breather before a play state. Basically, when we start the game, the user should press enter, upon which they are given another prompt that says press enter to serve. And then when they press enter yet one more time, then and only then do we go to the serve state, right? So we go from title to serve, then we go from serve to play. So it's sort of like an anti-chamber of sorts for our game. And this will be more clear coming up, but taken at that, right? Assuming that we have this screen that says press enter to play or pre-50 Pong, and then we press enter, and then it gives us another message at the top that says press enter to serve, and then another message, and then you press enter, and then that goes into the play state. Let's try to take a stab at implementing that as an exercise. We'll come back in 5 minutes, and then we'll not only do that, but we'll get started going from using that or implementing that serve state to then going into detecting points, detecting whether points are scored on player 1 or player 2. So let's take a stab at that for about 5 to 10 minutes. We'll be back, and good luck. See you in a few. All right, so recall the challenge was to add effectively a serve state in between the title state and the play state. So currently, if you're at the title state and you press enter, you'll go directly to the play state. But let's say we want a state that says press enter to serve before we actually transition to the play state. So if we go up to, let's say, where we're checking for whether we're pressing enter, and inside of this, we say, if game state is equal to title, then, well, this is where we want to transition to the play state, right? So we say game state is equal to play. And then game state is equal to serve, not play. Else if, so to be clear, if we're in the title state, game state should transition to serve, not to play. Else if game state is equal to serve, well, now this is where previously we're going to use the code we were using previously, which is to set the game state to play. So that takes care of the transition. Now, to make things a bit more obvious as to what's going on, we probably want to, when we're in the serve state, want to have different text show up than the text that shows up when we're in the title state. So I can say, else if game state is equal to serve, right there after checking to see if we're in the title state. If the game state is equal to serve, well, I'm just going to copy these 2 lines of code. Actually, these 3 lines of code. I want that to be I want to use the large font, and then I want to press enter up at the very top and centered, like we did before. But then I want to transition back to using the small font in case other code decides to print stuff after this, and I haven't properly set my font back to the small font. Usually that's kind of a handy thing to do if, in case you don't know maybe how your code's going to branch, and you think you might be writing some text to the screen, or if you're changing colors or the like, this applies as well. Reset back to some sort of default font that you're okay with rendering, or some color that you're okay with displaying, in case things go wrong. But we should be okay for now. So now if we're in the title state, we have the text from previously. But if we're in the serve state, well, we want to press enter. And actually, to be more specific, to be more explicit, I'm going to say press enter to serve. So at the very top, it'll be a nice large text, press enter to serve. This might actually be too large. It might actually, after all, need to transition this back to small font, now that I think about it. So why don't we do that instead? We'll use a small font, and then we'll get rid of this, because I just realized that using the large font for that much text will probably be too much for the screen. Maybe, just offhand, I think we use the small font here. So let's do that instead. So kind of ignore what I said, but also it's still true. We're still using the small font by default, so no need to reset anything after this text here. But assuming that everything worked according to that, we have the conditional logic here to change between the title and the serve state, and the serve state to the play state, and in accordance with also this new bit of code here to print some stuff to the screen. If I run this, if I press enter, it does indeed say press enter to serve. Notice the ball is not moving, and then I press enter, the ball is moving. So we probably are going to the play state after the serve state. So we have this serve state now, which is kind of helping us get ready to play. One thing that is missing is, of course, the scores. The scores aren't being displayed currently, and in Pong, typically the scores are always visible. So why don't we just crank that out real fast? I'm going to do it below, not inside any if statements or anything, because these should always render. But I'm just going to say, basically, let's do love.graphics.set font. I want these to be large font. I want these to be displayed with the large font. So we'll say love.graphics.set font to the large font. Then we'll do a love.graphics.print, not printf. I'm just going to manually place these. I'm going to print, well, okay, well, we got to print the score, but the score doesn't exist. So where do we put the score? Well, a great place to put the score. Let's scroll up to the top. Let's put it in player 1 and player 2. So let's just say player 1 score is equal to 0, and then player 2 score should be equal to 0. So now we have an initial score as well associated with our player tables, which will be obviously very helpful going forward. So let's go back down to where our logic just was in our draw function. Let's go ahead and now we can print player 1.score, right? It's going to start as 0. But I want to also manually place this. They're going to be a little bit to the left and the right of the center. So we'll say for player 1, virtual width divided by 2 minus 36. This just happens to be a value that I figured out that works well. And let's make it halfway down the screen. So let's say virtual height divided by 2 minus 16. And then let's do the same thing for the player 2 score. So player 2 dot score takes virtual width divided by 2 plus 16. This just happens to be a position that I know works well for the position for the player 2 score. And then we'll put this at virtual height divided by 2 minus 16. So it should go in the same place as the vertically as the other score. And notice that we're offsetting it by a minus 16 because things are drawn relative to their top left. So this is just offsetting it appropriately. And then the last thing we should do, just as good practice, we'll set ourselves back to using the small font in case we decide to draw more text later on. This is just good practice, probably not crucial, but in case you see weird fonts being drawn, weird sizes that you didn't anticipate, it might be because you forgot to set yourself back to some sort of reasonable default. So we have the scores being printed here. We had the scores being added to our tables, just score being set to 0. And then recall we also have the bit of logic that we just added a moment ago to account for the serve state. Now, if we run this, no matter what state we're in, we now see our scores being drawn to the left and the right of the center. And you'll see now that we've effectively achieved our visual goal. If we look back at the slide deck, for example, you'll see that we have basically the exact same thing drawn here on the screen that we now are implementing or now have achieved. Pixel perfect, I do believe, if memory's not mistaken. So we've made a ton of progress here in just a short span of time. Now, of course, there are a few key pieces of functionality missing. For example, being able to collide with the left and the right edge, detecting that, and then adding a point to the right person. Making sure that we test to see whether the top or the bottom of the screen has been collided with so that we can bounce the ball off the edges. And then, of course, lastly, checking to see whether the ball collides with the paddles and then bouncing it back towards the center. These 3 last pieces are kind of the last keys to completing Pong and making sure that we have a sort of cohesive game experience. And we'll be working towards that immediately. In particular, starting off with checking to see about those left and right edges and adding points. Can we go back to the player score, please? Sure thing. So player score is up here in the player table. So just make sure that you add a score key with a value of 0 by default. Okay. Going to the game state block real quick. Sure thing. So let's scroll down here to the game state block, which is in the love.key press. So within checking to see if enter or return is pressed, we want to basically say, are we in the title? If we are, let's go to serve. And if we're in serve, let's go to play. So an else if in that circumstance. It has to be else if, because if we just do 2 ifs, well, on one enter key press, we'll go from title to serve, and then we're going to check for serve and go straight to play, which is not good. We want these to be mutually exclusive in this case, or we'll have some serious issues. All right. Awesome. So on last, some folks asking for love.graphics. The love.graphics part's probably looking like the most dense piece of the puzzle, and it certainly is the most dense, but also relatively straightforward if we get our minds wrapped around printf and around the fact that all we're essentially doing is just printing values to the screen and also rectangles. Really, there's not a whole lot of intellectually interesting stuff here, but it can be the most apparently wrong if you mess any of this up, because it is literally the rendering code of the project. So I do understand if some folks are having a little bit of trouble if you've missed a parameter or the like. But definitely, as I've iterated before, if you feel discouraged or if you feel like you're behind, definitely rewatch the content. Take it at your own pace. Don't worry about not getting it 100% clear, because a lot of this is new. A lot of this can be kind of a lot overwhelming for some people. So definitely do not worry if it feels that way, because like I said, I've certainly felt that way myself in the past. Why use graphics.print instead of printf for the score? Kind of an arbitrary decision, but printf is good for centering easily in certain circumstances, and print is good if we know that we just want to kind of put it to the left and the right of a particular position. At least for me, mentally, getting it working perfectly with printf feels like a bit more work than getting it to work cleanly with print. So I personally use print in that circumstance, but printf, you could get it to work. If you divided the screen up into 2 columns and you right aligned player 1 score and left aligned player 2 score, you could certainly do that too. All right, and Attaché is asking how to make something partially transparent. You would set the color, you would do a love.graphics.set color, and then make sure your alpha, your last alpha value is less than 1. Between 0 and 1, but less than 1. And that's your opacity, your transparency. As it approaches 0, it approaches full transparency or invisibility. And as it approaches 1, it approaches full opacity. All right. Next piece of the puzzle is going to be left and right edges of the screen. So this is a perfect time to look at our update function, because recall that in update, our ball is actually performing the update going from left to right. So this is a great time for us to check, have we gone past the left edge or the right edge? And if so, let's maybe do some logic to account for this. So after the ball actually gets moved by its velocity, by its delta x and delta y, what I want to do is, if I'm checking for the left edge of the screen, and I apologize, my hands are probably right and left, flip for you, but this is my left, your right probably. But if you're trying to check for the left, edge of the screen, well, when it hits the left edge of the screen, the ball's x is effectively going to be 0 or less than 0, right? If it happens to go slightly over 0 or into the negative, depending on how much delta time has passed. So if we say if ball.x is less than or equal to 0, in other words, if it's touching the left edge or less than touching the left edge, if it's further to the left of that, we'll say then, well, if that happens, then that means player 2's gained a point on us. They've gone it past our paddle, so let's add 1 to their score. So we'll do player 2.score gets player 2.score plus 1. Recall, unfortunately, Lua does not have plus plus or plus equals 1, so we have to do things a little bit more verbosely. In addition to that, let's say maybe I want to reset the ball to the center of the screen, right? We don't just let the ball go on forever. It does go back to the center of the screen. Well, conveniently, we already have the coordinates to where the exact center of the screen is for our ball. If we come back up to our ball table, we have them right here, these 2 initial values. So why don't we copy those? I'm just going to scroll back down to update. I'm going to paste them in. I'm going to massage them a little bit. So it's not x and y, it's rather ball.x and ball.y gets those values. And I want to remove these commas as well, because those were only appropriate because we were defining them within the context of the table, right? So we're resetting the ball. We are adding 1 to the score. And when we do this as well, well, let's give the players a break. Let's go back to serving the ball, right? We don't want to just immediately start the ball moving in a different direction. Let's say game state equals serve, right? So now we recenter the ball and we set it to serve. So this should, in fact, when the ball goes towards the left, give us the result of incrementing player 2's score and repositioning the ball. So let's give this a try real quick. Hopefully it initializes some negative x value here, which it does, great. And indeed, we see that once the ball hits the left edge, which did off screen, because admittedly we haven't tackled the problem of the bouncing top and bottom of the screen yet. But once it hit the left edge off screen, it still worked. Player 2's score incremented, and you can see it says press enter to serve. We're now officially back in the serve state, which is great. Now we have a chance to reposition our paddles and get ready. But of course, the ball's dx is going to be the exact same because we're not reinitializing, re-randomizing that velocity. That's going to be one of the next pieces of the puzzle. But actually, before we even get to that piece of the puzzle, what I want to do is take a few minutes now to send a challenge your way to see, can you do the opposite for the right side of the screen? When the ball goes and touches the right side of the screen, can you make the same behavior occur, but add 1 to player 1's score and then give us back to the serve state? So I'll leave this code on the screen here and leave that as a challenge for the next few minutes and be back in just a few. So good luck, have fun, see you soon. All right, everybody, we are back to implement the collision of the ball, or at least the detection of the ball going past the right side of the screen. So let's take a look at that. Hopefully folks were able to adapt the code we use for the left-hand side. Obviously, there are a couple of minor differences that you'll probably have seen, but suffice to say, we'll go ahead and just do a else if here. This ball really can only be one. If it's going to be colliding with the left or right edge, it can only be one or the other. So we'll say else if the ball dot x is greater than or equal to. Now we want the ball, we don't check to see whether the ball's right edge has touched effectively the right edge of the screen. So we'll do something like ball dot x is greater than or equal to virtual width, right? Now that would work up until we consider that, remember, everything is relative to its top left corner. So if we do this, it's only going to trigger when the ball has completely gone past the right edge, because that's when the left corner will have passed the right edge. But we want to check to see if the ball's right edge is touching the corner. So what we'll do is we'll just offset this by ball size. So if we check to see whether ball.x is greater than or equal to virtual width minus ball size, which is 4 pixels to the left of the right edge, well, as soon as it hits the point where it's flush with that 4 pixels to the left of the right edge, we'll have correctly detected the collision. So once that's the case, well, we'll do what we did up above, except for player one, we'll do player one dot score equals player one dot score plus 1. We'll then just copy these lines of code here because they are effectively the same. Remember, this is just resetting the ball's position right in the middle of the screen, and then of course setting the game state back to serve. There's a little bit of repetition here, in particular these two lines here where we're resetting the ball in the middle of the screen. And folks might be tuned into the fact that currently as we mentioned previously, the ball's velocity is going to be the same no matter what. We're actually not resetting the velocity ever in our code. And so that's going to make the game feel very samey and probably not desirably so. So I think the right course of action right now might be to pluck off randomizing that velocity after every time we go back to the serve state. That way the game will feel different each time. And then we can start to pluck off the last couple of remaining pieces related to collision and the like. So hopefully folks are having an okay time. I apologize if things are moving a little fast. There's a lot here, but at least if conceptually you understand, you can definitely rewatch the content and things will probably make a little bit more sense. And if you follow along at your own pace, try to code some of your own additional features or modes or even your own games. That's really, frankly, at least the way that I personally like to learn stuff. But different people are going to obviously have different preferred means of learning, and that's completely fine, obviously. So let's go ahead now and do a couple of things at once. Let's minimize some of this code redundancy, and in the process, also involve re-randomizing our ball's velocity. Attaché says, I would love to take GD50. I'm very happy that you say that. I hope you do take it and that you enjoy it. We go over a lot more than just Pong. I can promise you that. So let's go ahead now and let's take these two lines of code. These two lines of code we've used in a couple of times now, a few times. And let's now actually make our own function, our very first own function, very bottom of the screen. Let's make a function called, let's see, what would be a good name for the function, I guess. Reset ball. Let's do something like reset ball, right? And in reset ball, I'm just going to paste those two lines, right? So reset ball effectively has the effect of taking our x and y that we've been repositioning in the center. It just does that currently. But reset ball also could involve re-randomizing the velocity. And recall, if we jump up a bit to the love.load here, we are doing just that. We have the math.random functions here, right? And remember, we're flipping a coin to randomize whether they are positive or negative velocities as well. So let's just copy that. And let's replace this love.load little chunk of code here with a function call to reset ball, just like that. And in fact, let's paste it as well down inside reset ball. Now reset ball encompasses not only repositioning the ball to the center of the screen, but it will re-randomize the velocity of the delta x and delta y. And if we come up above, back to where we were, here in where we are checking to see if it goes past the left or the right edge, we can also replace our two lines of reset code with reset ball. and just the same, reset ball. So now every time that we were previously resetting the ball to the center, we are now also reusing our randomization code. So let's rerun this. I press enter, serve. So notice it's going down to the left, a little slowish, not too slow. Let's see where it goes now. Oh, up to the top left. Okay, so it's changing now every time. So faster to the bottom left. Okay, great. And then kind of slow to the top left again. Are we going to get a right hand side ball here? There we go. Finally, we get one on the right hand side. And scores, 1 to 5. So, truly random. So you never know what the distribution is going to look like. But I guess not truly random, pseudo random, but feels truly random. We have now gotten rid of or taken care of the problem of not having a resetting of the randomization. So that's a big piece of the puzzle taken care of. Another big piece of the puzzle, as folks have noticed from just that little sample we just did, is that the ball is not bouncing off the top and bottom of the screen. We should probably take this into consideration as well. And someone's asking to show reset ball. My pleasure. Here you go. So recall it was just the 2 lines of resetting to the center of the screen in coordination with the code that we had in love.load previously, where we randomized the dx and the dy. And then following both of those, we flip a coin to negate the dx and the dy. This bit of code right here. All right, so once that's done, well, now that that's done, I should say, we should probably check to see about the top and bottom of the screen. Now, this is where I'm going to bestow upon all of you your final challenge for the evening or for the morning, wherever you might be located. And that is, we essentially have the pieces that we need, at least intellectually, right here. What I want to do is I want to make sure the ball, when it touches the top or the bottom of the screen, that it bounces back. So if it hits the top, if it's going up, it should go down. If it's going down, it should go up. So what we're going to want to do is a challenge for you at home. Code it such that when the ball hits the top of the screen, it bounces back down. And when it hits the bottom of the screen, it bounces back up. You're probably going to want to take a look at somewhere around here, maybe, to put it. I'm going to give you about 5 to 10 minutes. This will be the last challenge of the evening. And then we'll conclude the night with a collision function and questions. And this will have been 350. We're almost there. The goal's in sight, but I'm going to leave you all with for about 5 to 10 minutes for a last challenge. I know that was pretty quick since the last challenge, but this is the last one for the evening. So good luck, have fun. Be back in just a few. All right. So if folks found that that was a little bit much to bite off, totally understandable, and frankly to be expected if you're brand new. But you know, the way we improve is by challenging ourselves a little bit further every single time. So if you took it upon yourself to try your hardest and manage to at least make some progress towards it, or even accomplish it, then definitely pat yourself on the back. But we're going to go ahead and implement it now. So the goal, recall, was to make sure that when the ball goes to the top edge of the screen, that it bounces back down. And the same thing for when it goes to the bottom edge of the screen, that it bounces back up towards the center, so that the ball stays in view. This way we can also more easily actually hit it back to the other player when it gets to our side of the arena. So this is a perfect place or a perfect time to add more code to our update function. So update, remember, is kind of where you generally put, like, if you want to check for things happening, that's typically where you would check, is in your update function, or where you would slot it in. So we can kind of put it in a block right below where we check the left and right edges of the screen, because conceptually it's kind of the same thing, albeit with a couple of minor differences. So what I'm going to do is I'm just going to say, in much the same way that I did with the other block, if ball.y is less than or equal to 0, then now what we'll do is kind of, it's going to be a little different here than what we did up above, where we just immediately reset the ball to the center. Now what we want to do is effectively revert its y velocity, right? Because if it's going up and then we want it to go down, well, that's an inversion on the y velocity. It maintains its x velocity. It still goes from left to right if it's going in that direction, or right to left, or vice versa, or whatever. But now it's going to go, it's going to basically flip whether it's going up or down. In this case, whether it's going up, it's going to start going down. So if ball.y is less than or equal to 0, because recall everything's relative to its top left corner, we say ball.dy is equal to negative ball.dy. It's as simple as just making the ball's dy negative. Else if the ball.y is greater than or equal to virtual height minus ball size. So this compensates for the fact that things are rendered by the top left corner. We are going to not check to see whether the ball's y is at the very bottom, but 4 pixels above the very bottom, right? Minus the ball size distance from the very bottom. So that when the bottom edge touches the bottom of the screen, that's when we bounce the ball. So what we'll do is we'll say ball.dy is equal to negative ball.dy. And in this case, it's actually something we could condense theoretically into one line of code. So congrats if you were able to figure this out, but if not, no worries. Again, this is new content for a lot of folks. I totally understand that. And you should definitely feel, if interested, feel free or compelled to rewatch this and try again, or add more features or whatnot. But certainly it can take a few watchings, a few readings, a few implementations to have things fully click and feel comfortable. So no worries about that. So let's run this. Let's test this to make sure it works. It goes to the very bottom. It does work. It bounced. I was almost unable to make it down there in time, but we can also see it bouncing up from the top of the screen as well. So that's awesome. It actually is working correctly. Now you probably noticed if you were looking at my screen that I was not able to hit the ball back to the center, and that's also a huge problem. And actually the last consideration, the last major hurdle before we wrap up, is that the ball currently cannot collide with the paddle. And before we implement something like this, and I'll just leave the screen, I'll leave this here for just a few more seconds if folks want to keep reading it. But before we actually tackle collision between the paddle and the ball in the programmatic sense, I feel like it makes sense for us to look at a diagram to help illustrate what we're doing here, because we're actually going to get into a probably one of the more complex pieces of this, one of the more mathematical pieces. Relatively simple and straightforward, but especially the first time you take a look at this, this might feel like a lot to absorb at once. So we're going to use what's called AABB collision detection, or axis aligned bounding box collision detection. Now what this just means is when you have things that are axis aligned, boxes that are axis aligned, in this case, the paddle or the ball, they are not rotated. They are completely orthogonal, right? Because this algorithm would not work if they were rotated, just in the way that the math works here. You can see here that these two rectangles are overlapping. And all that AABB really is just checking to see, is one of the rectangles completely past an edge of the other rectangle. In other words, for example, this blue rectangle, is it to the right of the green rectangle, completely to the right of the green rectangle, or completely above it, or completely to the left of it, or completely below it? And more specifically, is the left edge of the blue rectangle to the right of the right edge of the green rectangle? Is the top of the blue rectangle below the bottom edge of the green rectangle, and so on and so forth for the opposite edges? It's really what we're checking to see whether one edge of this one rectangle is below or across the opposite edge of the other rectangle. And in the event that that holds true, we know that we don't have a collision. We know that that is not a collision. So what we do to determine whether we do have a collision is check those conditions and then return the opposite truth value of that mathematical expression. So we determine, are there any rectangles outside of the other rectangles? And then we return the opposite of whether that's true. Because if the boxes are outside of the other rectangles, or if one rectangle is outside of another rectangle completely, the edge is past the opposite edge, well, it's not a collision. So we return the opposite to determine, to spit back whether it is a collision, in other words, if that makes sense. So we're going to go ahead now, back to our source code, and we are going to write an implementation of this. And we're going to do this in a separate function, which makes the most sense to me. We're going to make a new function right above reset ball called collides. And we'll assume that it takes a paddle and a B, denoted as P and B here. So it's going to expect a paddle, it's going to expect a ball. So remember, those conditions, the 4 edges that we talked about, we need to check for those. So let's go ahead and do that. We'll say P dot X is greater than B dot X plus ball size. So this is checking to see if the paddle's left edge is beyond the right edge of the ball. And if that's the case, then we know there's not a collision. It's not a collision for sure. It can't physically be a collision. It's impossible, right? Or, literally the word or there, P dot Y is greater than B dot Y plus ball size. So this is checking to see whether the paddle's top edge is below the ball's bottom edge, right? B dot Y plus ball size. So in that case, it's also not a collision. And if we do the opposite, going the opposite direction, we accomplish the other 2 sides of our equation, the other edges. If we do B dot X is greater than P dot X plus the paddle width, right? We're checking to see whether the ball is to the right of the paddle, effectively, or whether the B dot Y is greater than the P dot Y plus paddle height. So this is the set of 4 conditions, recall, that are checking to see if we're not colliding, whether they're completely separated, physically separated rectangles. So we don't want to return this, because this is going to be, this is not, when they collide, this is going to return false, because these are not going to be true. But if these are true, that means there's not a collision. So we need to essentially negate this whole operation. Notice that I put a parentheses over here, because I'm going to encapsulate this entire thing in parentheses. Then I'm going to return not that whole expression. We're going to evaluate that expression, and then we're going to reverse the truthy value of it. We're going to, if it's evaluates to true, we're going to make it false. And if it's false, we're going to make it true. And then that will mean that collides will be accurate based on whether these conditions hold true or not. So again, just checking 4 different conditions to check to see if the rectangles are on opposite or past each other's edges. And if this is a lot and it feels like a lot and is confusing, don't worry. It took me certainly a couple of times to write this and read this and understand this. As long as you conceptually understand that, we're just checking to make sure the rectangles are separated. They're not overlapping. If their edges are opposite each other. That's all we're doing. It's a really simple physical geometrical equation, really. But taken in code, looking at this long line, it can feel like a lot. So don't worry if it is. Certainly look at it a few times, maybe look at the slide, try to visualize what's going on. But this is the simple way that we can collide, check to see whether any 2 rectangles collide. So given this collision function, let's go up to our update. Now, after I checked to see whether or not the bottom and the top edges of the screen have been crossed by the ball. Let's go ahead now and say if collide. So if it's the case that the player one paddle and the ball are colliding, right? If the edges are separated, or well, if they're not separated, rather if they're overlapping, given the logic that we've written down there. And again, don't worry if that doesn't make 100% sense yet. You can maybe focus on the conceptual content here, which is that we're checking for the collision, and then maybe reread that logic over and over again until it makes sense. But we're checking to see if it's true that player one and the ball collide. Well, that means that the ball has gone to the left, and we need to reverse it back to the right. So in this case, what we need to do is we need to say that the ball, its dx, should be negated, negative ball.dx. Not only that, but in the event that the ball has actually overlapped with our paddle, we need to reset the ball to be pushed back outside the paddle. Because if the ball is inside the paddle and never gets pushed out, well, it'll infinitely collide. It'll get stuck, actually, because this dx will be flipped negative every frame over and over and over and over again. We need to actually push it back outside the paddle so it moves to the right and is outside of the collision boundary of the paddle's rectangle. So in order to do this, all we have to do is just say ball.x. So we need equal to player one.x plus paddle width, because remember, things are relative to their top left. So we need to check the right edge. We need to put the ball to the right edge of the paddle, which means we need to add paddle width to it, paddle width to the player one.x, and that's what we assign to the ball.x. And then conversely, we're going to check an else if here on whether player two and the ball have collided. And if we do this, we'll do the same thing. Ball.dx is equal to negative ball.dx, but ball.x is going to be, so we need to make sure it's pushed to the left so that it goes to the left and is no longer colliding with our right hand paddle, player two. So we need to push the ball out to the left of the paddle. But remember, because things are relative to the top left corner, that actually needs to be pushed 4 pixels to the left of the paddle. So ball size distance to the left of player two. So what we'll do is we'll say ball.x is equal to player two.x. Whoops. Ball.x is equal to player two.x minus the ball size. All right, so let's go ahead now and run this. And I know it certainly probably felt like a lot. This is probably the most challenging part of the entire code base. And if it doesn't feel that way, pat yourself on the back. But let's go ahead and run this. And then I'm going to set up both paddles here to see if I can play as 2 people at once. Press enter to serve. Okay, and boom, the ball is moving off of the paddles. And same thing in that instance, it bounced, reversing its delta x immediately, preserving its delta y, flipping its delta y when it hits a ceiling or a ground, and then preserving its delta x accordingly. We could get fancy with this even if you wanted to, and we could say, okay, every time it collides with a player, maybe let's multiply that delta x by 1.02 just to keep it increasing. This gets faster and faster and faster as the game goes on, so that eventually it's impossible not to lose. We could certainly do something like that, but that effectively completes the core of Pong. Now, of course, we could also add the ability to check to see whether the score goes above 10, and then that's something that we would do in this bit of code here, where the ball goes past the left and the right edge of the screen, and you could maybe whip up some logic with the amount that you know now to say, okay, well, if that's the case, then if player two score is greater than or equal to 5 or 10, well, then let's set the state to game over. And if we're in the game over state, let's display the winner, and then let's press enter to transition back to the title screen, and then reset the scores back to 0. You could do all of that. That would be a great next step. But we don't have enough time probably to cover all of that. So I am instead going to open my slides here to show maybe some additional directions that some folks could go into following this, especially folks are interested maybe in taking GD50, for example, the first thing listed here, basic AI for one or both of the paddles. This is GD50's indeed first assignment for Pong, is to take what we've essentially written here, given admittedly that we don't have a couple of pieces in place, but add some AI to it, which seems simple on the surface, but actually kind of has a few gotchas in there if you get into implementing it, which you will find out before long. maybe replacing the paddles with images instead of rectangles, maybe adding music or sprite backgrounds or multiple balls that can be going on at once that can be in play and valid. So if any one of them gets past the paddle, then it's a point score. Maybe the paddles grow in size, which you talk about even in Breakout, which is one of the first few lectures in GD50. More advanced, you can maybe create a UI such that folks can choose what score they want to work towards dynamically at the start of the game. So if you only want to play to first to 5 or first to 10, or maybe a marathon first to 20 or 50 or 100, you have the ability to do so. And then even more sophisticated, related to what we just wrote, is the a sort of interpolated collision detection to compensate for the fact that if you keep increasing the speed of the ball, eventually it'll actually clip through the paddle altogether, and you won't be able to test to see if it's colliding on that frame. So you want to interpolate the basically chunks of the ball in the span that it's crossed during that whole entire last frame, which can be a lot if you gain enough speed. All of that are options and more. And this was pre CS50 Games Edition. I hope this was a nice taste of game development and a nice retro sort of flavored introduction, and at least sort of mentally not too overwhelming, even if folks were brand new to it, at least conceptually. Certainly Pong is very famous and a great intro, but we cover, of course, much more in GD50, like Mario and Zelda and Pokemon, and even 3D stuff like Portal and some other cool games. If you could all do me a favor, I know that we definitely appreciate this very much. Getting any and all feedback is super helpful for us. I'm going to paste this link. Actually, Valerie already did. But if you could definitely fill this out, give us a little bit of feedback, this would be much appreciated. It helps us be better at educating and doing what we love to do. So thanks all of you for tuning in. I'm not going to sign off immediately. I'm going to take questions if there are any, just so that if folks have anything lingering, I would certainly be happy to answer and elucidate. I'll stick around for a few minutes here, but that essentially wraps up what we did. And this code will of course go online, and so will the video and other resources following. But yeah, that was pre-50 Pong Games Edition. Do take GD50 if you liked it. We go over a lot more. It's a lot of fun, a lot of good stuff, in my humble opinion, of course. All right, I am